the ocean, the last frontier on Earth. So much is unexplored and unexplained. To change that, a kick-ass team of insanely talented specialists is setting out to push the frontiers of what we know about our oceans.
Oh my gosh.
Zoleka Philander, deep-sea scientist.
Being a deep-sea researcher means having front-row tickets to the best movie that everybody wants to watch.
Melissa Marquez,
Straight ahead, 12 o'clock.
shark biologist.
We just saw what no one has seen before.
Eric Stackpole,
Scan now.
ocean tech innovator.
I love building tools that allow us to see things in ways we've never seen before.
And Aldo Kane,
This is insane.
former Royal Marines Special Ops.
It doesn't get any more cutting-edge exploration than this.
Their secret weapon? The Ocean Explorer. The most technologically advanced research vessel ever built. There's never been a more urgent need to understand our ocean and the animals that call it home, because their lives and ours depend on it. This time, the team's following one of the ocean's most unique predators
Hammer, hammer, hammer.
to discover the superpowers
Look at the size of him.
of the great hammerhead. The team is powering through the Atlantic Ocean off the eastern seaboard of the USA,
Green light, green deck, we're lifting.
firing up the Ocean Explorer's armory of cutting-edge gear. They're on a mission to search out one of the strangest sharks in our oceans and one of the most recognizable animals on the planet.
That's what we're looking for.
The great hammerhead. These sharks haven't changed for millions of years. They are one of evolution's most eccentric creations. But why would nature select for a head shaped like a stealth bomber? Science suggests improved agility and enhanced electrosensor capabilities make this shark one of the most specialized in the ocean. Hammerheads are found off the coast of Virginia to the north and Louisiana to the west. But highly sensitive to temperature, every winter they migrate to the warmer waters of Florida. We think the sharks are navigating this journey by following the Earth's magnetic field. This field, generated by our planet's molten core, creates the magnetic north and south poles. It's believed that hammerheads can tune into this and use it like we'd use a compass. But as a mariner, I know even 1 degree out, and you're soon miles off course. So how do great hammerheads navigate so accurately across this vast ocean? With the hope of finding an answer, the team is in Florida. Their plan? To attach a camera tag to a hammerhead.
Welcome aboard.
They're joined by marine ecologist Aaron Spencer
Here he is. Welcome aboard. Let's go.
and shark biologist Matt Smuckle.
And ready to tag some sharks?
Hammer.
Hammer.
The only way to catch a hammerhead is with a baited line. It might look stressful, but these sharks are tough, and their well-being is the team's top priority.
Get out of the way, guys. Get out of the way.
All right.
All right. Coming up. Neutral, neutral, neutral. Go for dorsal. I have the dorsal.
The team works fast to take vital measurements.
80 to caudal. 180 caudal, 180 caudal. 186 for fork length.
186.
Check the sex, Aaron. Remember sex?
They attach a tracking tag
All right. Yeah. Secure.
and release the shark in under 5 minutes.
It's a physical task holding on to that main dorsal fin. You know, it's amazing, but it's like it's a live animal, and it's, you know, you are firmly tuned, you're focused.
We have 30 seconds to release. You guys on tail, count it down.
3, 2, 1, tail's loose.
Looking good. Swimming off.
All right. Nice job, guys. Nice job.
How many hammers have you worked up like this?
So we've worked up quite a number of hammers, but it's the first time we've been able to put out a video tag with our speed sensor. And so hopefully we're gonna get some good footage to also match up maybe with some of that speed data.
The tag is designed to fall off within 24 hours.
What's that? Just at like 11 o'clock?
See that floating?
Tag?
Look how small that is in the water.
Nice.
We have a tag.
So you're gonna see what the shark sees. Are you ready? You can see him turning to look left and right.
That's amazing, getting that
Right,
perspective
I
of the
know.
head moving.
We're moving up towards the surface. And he's right at the surface. Like, you can see the water patterns at the surface. Now we're back towards the bottom, down to about 80 meters.
It looks like that's a choice to either be up at the surface or down. It's not just like a wandering.
You're actually right, because like if we look closely, we can actually see this up and down movement of the shark. And it resembles a yo-yo pattern. And it looks like it happened 20 or 30 times. And I'm just wondering, why would the shark be using so much energy intentionally moving up and down? Do you think it has something to do with its magnetic sense?
For a shark, the Earth's magnetic field is clearest at the surface. But the seafloor also has local magnetic fields created by geological formations. It's believed that hammerheads yo-yo up and down to create a virtual magnetic map. This map allows them to plot a more accurate course so that they can eventually find their destination hundreds of miles away. Some hammerheads are content wintering in Florida, but others keep going, crossing the Gulf Stream into the Bahamas, and eventually even pinpointing the tiny island group of Bimini. Following in the wake of the great hammerheads, the ocean explorer sets sail. Matt's been studying hammerheads in Bimini for years and knows the best place for Eric to meet the locals.
Okay, let's do it. Ready. All right.
This feeding station attracts more than just hammerheads.
Bull shark. So those are the sharks that, have a pretty bad reputation. Looks like a shark that means business. Eric, hammer, hammer, hammer. Look at the size of him. He must be at least 12 feet long. I just need to keep telling myself they don't eat people. They eat stingrays. So do you recognize this shark? Yeah, this is Atlas. He's one of the regulars around Bimini. That he's been coming back at least 6 to 7 years. So he's an old friend. Maybe he recognizes you as well.
Seeing Atlas return to this island year after year is incredible. I mean, it's a tiny little speck in a big ocean, but you don't get that ability without having some crazy navigation skills. But I guess that's evolution in action.
Thanks to Matt's research, we know hammerheads like Atlas keep coming back to Bimini, but it's only 7 miles long. Even with geomagnetic navigation, finding this place is a long shot. So how do these sharks get here? Could they be using other senses to help guide them in? Zuleka wants to map the seafloor using the Ocean Explorer's sonar, in the hope it uncovers an answer.
The seafloor in this area has never been mapped to this resolution before. And so I'm really hoping that we pick up on some anomalies, different features that can give us insights as to how these hammerhead sharks are coming here to Bimini.
The ship scans for 12 hours straight, mapping this area for the very first time and generating detailed images of what lies beneath the surface.
Wait, so this has got to be exaggerated relief, right? I mean, these are really sharp features that we're seeing here.
It's not exaggerated.
This is actually what it looks like. There's huge, tall pillars sticking out of the bottom of the ocean.
Yeah. This is very exciting.
The sonar reveals a labyrinth-like terrain hidden on the ocean floor.
These are meter marks. It's 100 meters. So it's like a 300-foot tower. I mean, I'm just trying to picture that standing up from the bottom of the sea.
These towers are the height of the Statue of Liberty.
This is off the west coast then.
Right on the drop off to the Gulf Stream.
Is this what you thought? Is this a surprise?
We didn't know that this was there. There's a lot going on there that's really exciting.
It would be great to do a sub dive and to get like some visuals on what's there, We always go out to find the known unknowns, but we stumble on the absolutely unknowns, like something we've never seen before.
To discover if these towering outcrops could be influencing the great hammerhead's navigation, Zuleka and Matt take a dive into the deep.
This is real exploration. No idea what we are getting ourselves into.
Roger, so that's Neptune off deck.
Copy that.
Roger, so there's Neptune venting now.
Venting now.
The sub-team will be accompanied by the remotely operated vehicle. Controlled from the surface, it sends up live pictures from the seafloor.
Control, this is Neptune, passing 500 meters.
Descending depth under keel 21 meters. Over.
Roger.
Where these pinnacles are is right in the Gulf Stream, and that Gulf Stream is cranking north the whole time. There's no rest there.
It's a strobe color.
The Gulf Stream is the fastest ocean current in the world, running up to 5 miles per hour. And 1,600 feet down, the deep dive team is feeling its force.
Zuleka, can you see?
I can't see much.
The strong current is picking up sediment, and visibility is reduced to near zero. Conditions us sub-pilots referred to as off-nominal. Out of the gloom,
Oh man, that's massive.
a towering pinnacle.
Oh, this is so beautiful.
Control, this is Neptune. Intention is start working up wall. Over.
Roger, walking up wall.
Oh my gosh. A mountain underwater.
Shark port side.
Oh yeah. There it is, their night shark.
Night shark.
Oh, came right under the... Came darting under the...
There it is. Port. That.
Oh. He darted off pretty quick.
Yeah.
We are at the top.
Oh, and look at this.
Control, this is Neptune. We are at the top of the first pinnacle, depth 408 meters.
The minute we got to the top, it was beautiful. Absolutely stunning.
Guys, so do you want to move to the next pinnacle?
Yep.
Yep.
Now the sub and ROV teams begin to survey the pinnacle field, looking for sharks.
Oh, little shark here.
Oh yeah.
A dusky smoothhound,
Oh, look, shark.
and a tiger shark. Just like Atlas, tiger sharks must cross hundreds of miles of open ocean to find their way to Bimini. And this complex field of pinnacles could hold the key to getting them there.
When I'm navigating, I don't just use a map and compass. to find out where I am. I use other senses like sight to look for landmarks, and that's what we think sharks are doing, but with smell.
As water from the Gulf Stream hits the towering pinnacles, nutrient-rich water is forced to the surface, creating distinctive scent trails. Sharks like Atlas, with their powerful sense of smell, are able to detect these scent trails and follow them, like an underwater signpost pointing straight to Bimini. The discovery of this vast pinnacle field could finally answer how these sharks locate this tiny group of islands. But once here, does this unique adaptation give them any other advantages? The team meets in the mixed reality lab to investigate.
I noticed just how huge that cephalofoil is, and then underneath it, how small in comparison the mouth is.
You can tell they're just not designed to take down massive prey, but what they are designed to do is actually chase down rays or smaller sharks and use that big cephalofoil, almost sometimes pin down the animal, and then that mouth is right underneath there, and they could potentially, you know, bite off one of the wings of a stingray and kind of incapacitate it.
But also they're a sensing machine, right? They've got all these sensing olfactory glands. They can detect electrical signals from fish, and I imagine that's got to be useful.
Yeah, and having all of those senses spread out over a wider area can probably help them hone in on certain things, like a stingray that's buried under the sand.
So it's the spread out array that's making the hammerhead sharks such an accurate hunter.
Absolutely, that's what allows them to be such an efficient predator.
To observe the shark's hammerhead in action, Aldo and Matt are going out with a camera tag designed to give them a view rarely seen. But to attach it, first they must get up close and personal with the hammerheads.
These sharks are huge. They can be up to 900 pounds. And when you're in the water, they are all around you. You need your head on a swivel. But with this mask, you get quite a lot of tunnel vision.
Shot coming in your right. All right, here we go. Here she comes. Almost. Coming in again. Man, that's on. Yeah, that one looked like it went on really well. Top side. If you copy, that's successful. Deployed tag.
After 8 hours, the tag releases. And once retrieved, the footage is ready to view.
You know, you can actually just see what a nice view these cameras are giving us of what the shark's actually doing in that habitat.
He's got his head down and scanning back and forth. It looks like he's hunting.
He's cruising along relatively calm, probably looking for some prey there.
Yeah, they generally cruise at 5 miles per hour, and they can burst to like 20 miles per hour. Look, he's picking up speed. He must have gotten his eyes on something.
With its wide-angle field of view, this camera tag reveals where the great hammerhead is hunting.
That little strip along the reef where you kind of have the convergence of two habitats. You have the seagrass flats coming to meet the reef area. That is the area that they're using most of the time, and probably hunting in both of those types of habitats.
This is nighttime now.
Even in the pitch-black waters of the night, using its electrosensors, this hammerhead
Fish!
can still detect prey.
Whoa! He senses the fish and goes precisely at it. He's sensing the electric field or vibration, this network of sensors that you find along this broad head.
No luck this time, but the team has gained key information on where the hammerheads are hunting. Eric and Matt head out. Their destination? The seagrass flats of Bimini.
It's amazing because this is a really shallow area. I wouldn't have expected hammerhead sharks to come around here.
These shallows are home to the hammerhead's favorite prey, the southern stingray.
Look at all the stingrays. Let's see how they're all right up close to the shore.
These waters offer the rays protection and a place to hide. Too shallow for most predators, but not the great hammerhead. It's a shallow water specialist. And these rays carry the scars.
You can see right there the base of her tail. She actually no longer even has a barb. So you can imagine that might be from a shark coming in and biting off a section of that tail.
Now they know what and where the hammerheads are hunting. The team sends up the helo. If the aerial crew can capture footage of a hunt, the team on the ship will see how the hammerhead is uniquely adapted to life in these shallows. The aerial crew returns with footage to share. Once again, the shark is head down looking for prey. And this time, it finds it.
The tail movement is wild.
Oh!
Oh, yeah.
Look how quick it can turn.
To lock on this stingray, the hammerhead attacks from the side.
These waters are only 1 meter deep. It's really well adapted for hunting in these shallow waters.
As the water starts murking up, she's still able to use all of her other senses besides sight to keep tracking that ray down.
In this visibility, it must be using its electroreceptors to detect the electrical signal from the ray.
This is so wild.
This is really a gem of an encounter.
Yo, hectic. Look at those sharp turns.
The shark is trying to pin that ray down, whereas the ray is trying to come up to the surface, which is basically the safest spot because the mouth is actually on the underside of that shark.
The hammerhead is making much tighter turns than I would have pictured possible for an animal that size. You know, maybe even the cephalofoil is useful as being a sort of extra control surface to help it get those tighter turns.
It just shows you how powerful and agile they are.
I mean, the hammerhead is like a perfect ray hunting machine.
Right there.
Yeah. You can see the instant that that ray is captured.
Rarely filmed in its entirety, the hunt lasts nearly 4 minutes. A long, arduous battle of attrition. Finally won by the great hammerhead.
It's the ultimate shark for this environment.
In their time following the great hammerheads, the team has deep dived into the world of this mysterious creature.
The great hammerhead has a sixth sense, opening up a magnetic map, leading it across the ocean, and that is just incredible.
They've revealed hidden landscapes on the ocean floor.
Oh my gosh.
Absolutely stunning. Every single time we scan the seafloor, we find something that we never knew existed. And these are the sort of clues that help us solve the greatest ocean mysteries.
And they've captured images that offer a rare insight into the lives of these little understood creatures.
I mean, the camera tag got us right in there, and we got to spend a day watching what the shark does from its perspective.
The team was able to study hammerheads here because the Bahamas is a shark sanctuary. But elsewhere in our oceans, great hammerheads are critically endangered, and they need our protection. We have to do all we can to safeguard the future of this extraordinary species. The ocean, the last frontier on Earth. So much is unexplored and unexplained. To change that, a kick-ass team of insanely talented specialists is setting out to push the frontiers of what we know about our oceans.
Oh my gosh.
Zoleka Philander, deep sea scientist.
Being a deep sea researcher means having front row tickets to the best movie that everybody wants to watch.
Melissa Marquez,
Straight ahead, 12 o'clock.
shark biologist.
We just saw what no one has seen before.
Eric Stackpole,
Scan now.
ocean tech innovator.
I love building tools that allow us to see things in ways we've never seen before.
And Aldo Kane,
This is insane.
former Royal Marines Special Ops.
It doesn't get any more cutting edge exploration than this.
Their secret weapon? The Ocean Explorer. The most technologically advanced research vessel ever built. There's never been a more urgent need to understand our ocean and the animals that call it home. Because their lives and ours depend on it. This time, the team takes on a deep-sea shark
She's huge.
and get closer than they ever imagined.
Oh, she just hit the sub.
The Ocean Explorer is in the Azores. A group of volcanic islands in the middle of the Atlantic Ocean, 1,000 miles west of Portugal. For this mission, the team is heading into the deep to uncover the secrets of one of the ocean's most elusive creatures. The six-gill shark. These animals live at depths of over 4,000 feet and are so perfectly adapted to the abyss. It's believed they've barely evolved in 200 million years. They're as old as the dinosaurs. Six-gill sharks are secretive. I've spent hundreds of hours in subs I've only ever caught glimpses. They can live so deep, they're really difficult to study. So the team is here to push the scientific frontiers of what we know about these animals.
We will be rolling the subs out in just a couple minutes.
To reveal the shark's mysteries, the team will make a series of dives into the six gills world.
I've always been fascinated by the deep because it's so unusual. It has this feeling of being scary, but your curiosity makes you go anyway.
Move into position for the sub launch.
Their ultimate goal is to tag a shark in an ambitious plan.
Nobody has managed to tag a six-gill shark from a sub at depth and get the data back. So what we're doing here is really pushing the boundaries.
Ready for battle.
Melissa Marquez studied sharks for her PhD, but she's never come face to face with a six-gill.
I'm gonna be a little intimidated if I've got a six-gill coming straight at us in the sub. I mean, these are big animals, and it definitely, if it wants to, clamp onto some part of the sub and shake us around a bit. Just through here?
Just this way, up the steps, sit here, hands either side, and lower yourself down.
So yeah, a little bit nervous of getting up close and personal with them, but really, really excited.
The team is joining forces with Jorge Fontes and Pedro Afonso, shark scientists from the University of the Azores.
There's amazingly little known about these creatures, in spite of the fact that they are the top predator.
Right, can I? Yeah. Just get your feet there and then down onto the seat. It's good.
The first mission is to observe these well-adapted six-gills which survive in a cold, dark world of intense pressure, and to get an idea of how many there are in this area.
Clear. SO Neptune, hatch secure, life support running, safety brief complete, ready for the water. It's really happening.
It is.
You ever been in a sub before? Nope. My first.
It's 10:30 p.m. Pedro knows where the sharks hang out at night, but until now, he hasn't had a chance to go there.
Okay, bridge, all ready.
All stations as so, launching Neptune.
We know that the sharks spend their days in the depths of the ocean, and that every sunset, they start an epic 3-hour journey, nearly 1,800 feet up to this island ledge. Melissa and Pedro are hoping to meet them there.
Down here, light barely penetrates, and temperatures are just above freezing.
See the bomb?
Yeah.
Yep.
Really close.
Yep. Now we see it. Okay. Here we go.
Just so much biomass here. There's got to be some sort of nutrient-rich water here, some sort of upwelling to explain just how much we've got going on right now.
Melissa and Pedro will stake out this ledge for 8 hours. Just 20 minutes in, a shape emerges out of the darkness.
Shark!
Okay, here we
shark.
go. Port side, port side.
A 6-gill shark.
That's huge. Adult, definitely an adult. About 15 feet long.
Female. No. Yep.
Yeah, female.
Males are identified by their claspers, their sexual organs, under the pelvic fin.
It's so interesting that she's so sluggish. Guess she's conserving her energy. I mean, it's cold out there. It's only 39 degrees.
The 6-gill is different from almost all modern sharks. It has 6 pairs of gills instead of the more normal 5, a relic from the ancient conditions they evolved in.
They really look like a prehistoric creature.
Literally unchanged since the Jurassic. Perfectly adapted. 6-gill sharks are the masters of the deep. They've got specialized eyes that actually allow them to see in really low light conditions down there. And that area is pretty hypoxic, so there's not that much oxygen. So their blood is actually adapted to being able to extract more oxygen from its surroundings, so these animals can actually thrive down there.
This close encounter is a good start, but we need to know more about these Jurassic sharks. No one knows how many 6-gills are living here, so Melissa and Pedro are carrying out a population survey throughout the night.
Think it is? Yep, it's coming.
Do you see it?
Yep.
Oh, yeah, there it is.
Yep. It's coming.
Shark.
Shark?
Yep.
Small one?
Yep.
Small one?
Oh.
Yeah. Not so small.
No, not so small. These sharks were showing all different types of personalities. Stop. She's under, she's under.
The hell of a big shark.
Some were really interested in the sub.
The big tail.
Oh, it's really close.
You can feel the power.
Some wanted nothing to do with it.
As the hours go by, they count 11 6-gills, 1 juvenile male, and 10 females.
It's interesting that we haven't really seen any males here, just that one. It's mostly just been females. No boys allowed, females only hang out.
Shark mating can be violent, And outside the breeding season, many species of shark carry out segregation of the sexes. It looks like this could be happening here. Our team has confirmed that this is a 6-gill hotspot. Now, the likely reason they come here is to feed. But how are they hunting? To find that out, the team is attempting to tag a 6-gill from a sub. The submersible team has fitted the tag deployment rig.
Set of lasers here, and that'll give you an approximate position within a few centimeters.
The whole team is feeling tons of pressure because there's so many things that could go wrong when doing this from a sub.
Everything's got to line up perfectly to make sure we get this once-in-a-lifetime shot.
There's only been one previous attempt to tag a 6-gill from a sub, but the data was never recovered. For this mission, Pedro and George have developed a high-tech prototype.
These electronic tags allow us to go much further into a window onto their behavior. They combine very, very fine-scale sensors that tell you the movements of the animals.
Succeeding in this mission will mean getting even closer to the sharks. All the planning has come down to this dive. The pressure is on from Melissa and 6-gill researcher George Fontes.
You just need to find the right shark with the right attitude that has to be confident and get in the right place at the right time. So the tension builds up.
The tagging system is carefully primed, ready for firing.
I think we're good.
Okay, guys, what do you think?
Yeah, looks good.
This is going to be shark bait. This is basically the way that we're going to get the 6-gills to come toward the sub. Oh, God, that's gross. I'm going to smell for days.
All stations are so, launching Neptune.
The sub is diving in parallel with the ROV, the remotely operated vehicle, which sends a live feed back to the control room, where the rest of the team can watch and hope.
There it is, lower right.
Observing animals in the deep is one thing, but trying to tag one at depth, that's a different ball game altogether.
As the sub descends to the shark's hangout, they encounter a shoal of boarfish.
Whoa, look at that.
It's a really dense aggregation. The lights of the sub could be illuminating the plankton they feed on, and they've come in to eat.
These guys are bait fish. Everybody eats these guys.
Have you ever seen so many fishies?
Very, very few places. This is pretty wild.
These boarfish are everywhere.
Yeah, feeding frenzy.
Is it just because of the bait? It's got to be.
Could be the lights.
Control, Neptune, I have you loud and clear. On bottom, 255 meters.
Copy, Neptune.
Okay, I'm gonna hand that to you.
It's midnight, and the sharks have completed their journeys from the deep. But will they come towards the sub?
Come on, Big Mama. Hey, you guys, we got a shark. Yep, coming in, it's coming this way.
Oh, wow.
Okay, well, here we are.
I love how she's really taking her time, just assessing the situation.
It doesn't seem super excited about the bait.
wonder what's distracting it.
Come this way.
Come on.
This adult female has detected a morsel of fallen bait and avoids going up to the sub to feed.
Oh, you're kidding me. You cheeky girl.
The sub team must be so frustrated right now.
I'm frustrated.
I have lost sight of her. Oh, big shark! There's two.
Oh, there's two of them now. Oh my gosh.
Well, that might get them competing for the bait.
6 gills will congregate if there's food around, and that can lead to aggressive behavior.
Okay, we got that second one right there.
Okay.
Whoa, she just hit the
Oh,
sub.
just hit the sub.
He's under the sub.
Oh, it doesn't matter.
With a shark in direct competition, this female has made it clear she is large and in charge.
You're not armed. When you want to be armed, you let me know.
It's a good time. It would be a good time now.
Okay. Lasers are on.
Number one, right?
All right, it's armed.
Okay, this could be it.
All right, it's heading this way.
Slow.
He's gonna take it. He's gonna take it. Take the shot.
Ah, damn it.
Oh.
I can't believe it.
Shore's overshot by a matter of inches.
We're not done.
We have one spare.
If they can't get this tag on, they will fail in their mission.
Oh, there we go.
Another 6 gill. This one is alone, and she's focused on the bait.
Smell that nice blood. Yeah.
There you go.
The shark needs to follow the end of the pole to the bait and line up precisely in the laser beam.
This is a big shark.
This is it. You got this.
Wait until you see the lasers.
This is it.
Right here, coming this way, this way, this way, this way.
Nice one. Camera tag away.
Yes!
Camera tag away.
You did it!
They got it.
You
It's
got
tagged.
it. You got it. Oh, yeah.
Wow.
The tag is suspended 6 feet above the shark. They can now, for the first time, follow its movements in detail through the deep.
Here's a shark coming right toward us, and I think that's the tag. This is the one we were holding just moments ago. This is in our lab up on the desk.
That's really cool.
I'm really excited. We've successfully tagged a shark. And if all the electronics are working properly and the software is working properly, we're recording data that basically no one has ever had before.
But the shark is in no rush to leave.
You're back for more, huh?
You can have some fish, yes.
Look at her eye.
Oh, wow.
Look at it roll back. 6 gill sharks don't have that nictitating membrane, so they need a way to somewhat protect their eye, just in case prey fights back.
The tag won't hurt the shark. Its sensors record speed, depth, and movement, for the next 12 hours. Then it detaches and floats to the surface. But if the team can't recover it, they won't find out how the six gills are hunting. The next day, the tag has surfaced and pinged a satellite with its GPS coordinates.
So I'm going out to collect the tag. If I can't get the tag, then all that data will be lost. And that means all the hard work of tagging the shark will be in vain.
The precious tag is being swept dangerously close to the cliffs.
Guys, keep your eyes on the water now.
Tag! Tag! Okay, Aldo, I'll get on the starboard side of it, so you grab it on port side. Yeah. See it? Yeah, seen.
Oh man, this is close, huh?
Aldo has one chance to pluck the tag from the swell.
All right.
There we go.
Good job, man.
Good job.
The tag has been successfully retrieved, but what's it going to show us? The information from the six-gill tag has been processed, and the results are ready to be revealed.
What do you got for us?
I have got some of the best footage captured from our many hours of shark exploration. Shall we hit it, Maestro? Okay, here we go. So this obviously is the light from the sub as seen from the shark.
That's the sea floor.
And I noticed in some other parts of the footage, you could actually see the fish scattering as the shark moved through. This is kind of how the shark sees it, you know? So you almost get in the mind of the shark. There's George.
I've taken so many pictures of sharks in my studies. Now a shark's taking my picture.
Now it's chomping down on the bait.
The motion sensors on the tag will detect when the shark is eating, even if you don't have video.
Oh, right, because it's bobbing up and down as its head moves.
But can the other sensors reveal how the shark may be hunting here?
Here on the top line will be depth. So we can see that from here, he was going away from the sub for periods because he's going deeper, and then he's coming back up, then he's going deeper, he's coming back up. So it is roaming, he's exploring. Then you can see as we go over, then this is a big climb.
Yep.
You know, it's climbed up to 200 meters, then it goes back down again. And then the nice thing is, towards the end of the deployment, it just starts going down. And this is when sun is about to rise.
So as the sun's coming up, the last thing we see the shark doing is going down deeper into
Straight
the abyss.
down. Here you have speed. So you can see speed change, varied a little bit.
Do you see a few places, like here and here, where the speed increases rapidly for a moment? What do you think happened there?
Could it be predation?
Could be. Could be.
And you know, it's interesting it's coming up because I know a lot of these predators, they look for silhouette. I mean, I guess there's no light at this point. I thought maybe it could...
Maybe enough for them. You know, just moonlight is enough for them to see a silhouette because they have very sensitive
So it could have from below seen its prey, come up, eaten it. That's what this spike is, and then it goes back down or something.
It could be.
The shark's upward movements are intriguing and may be helped by its huge oil-filled liver that accounts for over 20% of its body mass and makes it buoyant. This buoyancy could be behind its hunting strategy.
Some scientists suggest that six gills are ambush predators gliding up to capture their prey. They just hit them from below.
Yeah, I mean, we know from their gut content that they're mostly eating things that are way faster than they are. So stealth gliding to sneak up on their prey makes a lot of sense.
And you see the nice...
The tag results suggest an interesting hypothesis on how the shark may be hunting, but our guys need more information. Can they capture footage of a six-gill actually predating? To give themselves the best chance, they have to time their dive perfectly to when there's maximum prey. We know that at night, many creatures come up to feed. A mass vertical migration occurs in all the world's oceans, triggered by the rise of plankton, fish, jellies and squid travel through the ocean's twilight zone, and following them, larger creatures. If they can hit the peak of this vertical migration, Melissa and Pedro may have a chance of recording a 6-gill on the hunt.
Keep that biology sharp eye on the camera, yeah?
No pressure.
Aldo is also preparing a dive, but his will be in the shallows to understand the scale of the vertical migration in the Azores. As a former Special Ops Royal Marine, Aldo is the only member of the team with the experience to lead this night dive.
When you have moving boats and diving operations, and then you add into the mix nighttime operations, you can quickly and easily lose control of things.
It's 11:30 p.m. Only if they've timed their dive perfectly will they fully experience the vertical migration.
Okay, guys, you ready? So, 3, 2, 1, go.
Guided in the darkness by his dive computer, Aldo descends 60 feet. Immediately, he's engulfed by the smallest creatures in the ocean, the plankton that underlie the entire food chain.
This is the vertical migration that we're talking about. All of these fish coming in to feed on the plankton which has made its way up to the surface. That's amazing. Look at all the fish coming in below us now.
Tonight, the rise of the plankton is followed by something else. Purple stinger jellyfish.
It's amazing seeing them all migrating up to the surface.
What appears to be a few at first grows into a mass bloom.
I've never seen anything like this. There's literally thousands and thousands of jellies. It's one of the strangest things I've ever seen. Just stunningly beautiful in its own way.
The vertical migration is at its peak. The deeper waters are now rich with shoals of fish, and the ledge, where the sharks make their nightly visits, is a hive of activity. It's dinner time.
It's our anglerfish. See, that's the lure. Look.
Oh, yeah.
He's lifting the lure, right?
Yeah.
See, he's waving the lure.
Yeah.
That's what he uses to attract the prey. Then bunch of rays around.
That's so cool. We just saw predation.
Conger eels rely on the vertical migration for food.
They're in feeding mode. That's for sure.
Yeah. Actually being down in the sub and putting faces to the animals that make up this migration. You've got fish eating smaller fish. You've got the skates and the rays burying themselves and eating their own fish. This happens on a massive scale every single night in our ocean. And the fact that I got to kind of just sit in the middle of it and observe it all is mind-blowing.
These large creatures are perfect prey for 6-gills. But can the team film the sharks actually hunting? This female has completed her 3-hour journey up from the depths.
There we go. Now it's coming a little bit closer.
Closer?
Yeah, because I got her on the camera.
Yeah, she is.
She's staying close to the seafloor.
Something's got our interest.
A conger eel. The conger eel escapes. But this six-gill is on the prowl, and she's not the only one interested in the seabed.
Oh, there we go.
Yep.
She's really low to the ground.
Like all sharks, six-gills have highly sensitive electrical sensors around the nose, which can detect the smallest muscle twitch of its prey. She may be seeking rays hiding out under the sand. Suddenly, she makes a move. She thrusts with her tail to get on top of the prey.
Do you see anything in its mouth?
Capturing this behavior on camera is incredibly special and will help the team understand how this top predator hunts.
Oh man, that is quite something. See why we want to study these guys?
Yeah, of course. As a scientist, you always hope you get to experience the rare and extraordinary. It doesn't get much rarer than this.
That footage is incredible. Has that been filmed before?
We don't think so, which makes it even more exciting because this is probably a first for science. And, you know, you don't really get that often. You know, the data from the tag was telling us one thing, but our own eyes are telling us something completely different.
Right, on the tag data, I assumed that it was like an ambush predator where it sees maybe like the silhouette from below and snatches its prey.
But that's not what we saw here. It's using its positive buoyancy to actually lift up its rear end so its nose eventually actually points down into the sand once it finds prey, and then with that really powerful tail, grind down into the sand.
So it's using its positive buoyancy to glide up the gradient and then pin whatever it is, the ray, down into the seabed.
That's it. And that's not to negate the theory that we got from the tag. It just means they might be using different hunting tactics for different prey. It's mind-blowing to see a brand new to science data point that we didn't have for these animals before.
I'd call this a pretty successful mission.
100%.
Yes.
100%.
In their time here, the team has gained important new insights into the lives of the six-gill sharks. They've observed how they're perfectly adapted to the abyss,
It's so interesting seeing them be so sluggish.
discovered their different personalities,
You cheeky girl.
and confirmed that a large population of females live here.
Only a handful of people have been able to see these sharks from a sub at depth with their own eyes. I feel really lucky to be one of them.
There it is. Lower right.
By successfully tagging a six-gill from a sub,
Oh yeah!
they've gained a whole new set of scientific data.
This is awesome, guys. What we've done has paved the way for six-gill research, and it has been awesome to be a part of this mission.
They've explored these rich waters of the Azores at night,
It's one of the strangest things I've ever seen.
Being in the middle of that vertical migration was just unbelievable.
The greatest achievement has been capturing the six-gill's predation behavior.
We know so little about the residents of the deep, but today we have gained some valuable insights on how these prehistoric animals have survived.
Some of the 6 Gills secrets have been uncovered, but there's still so much more to learn about these mysterious sharks of the abyss. The ocean, the last frontier on Earth. So much is unexplored and unexplained. To change that, a kick-ass team of insanely talented specialists is setting out to push the frontiers of what we know about our oceans.
Oh my God.
Zoleka Philander, deep-sea scientist.
Being a deep sea researcher means having front row tickets to the best movie that everybody wants to watch.
Melissa Marquez,
Straight ahead, 12 o'clock.
shark biologist.
We just saw what no one has seen before.
Eric Stackpole,
Scan now.
ocean tech innovator.
I love building tools that allow us to see things in ways we've never seen before.
And Aldo Kane,
This is insane.
former Royal Marines Special Ops.
It doesn't get any more cutting-edge exploration than this.
Their secret weapon, the Ocean Explorer. The most technologically advanced research vessel ever built. There's never been a more urgent need to understand our ocean and the animals that call it home, because their lives and ours depend on it. This time, the team ventures into the realm of ancient ice giants.
Oh, shark, shark!
The Ocean Explorer is headed where most ships fear to go. The ice of the Arctic Ocean.
A bit in disbelief that we're actually here.
Yeah, I'm just trying to take it all in.
A treacherous journey to a hostile world.
Being one of the few people that are here, that comes with great responsibility.
Yeah.
This is definitely an area that has never been really covered that well before. The instruments that we have on board are perhaps going to be the first to see this stuff.
Such an amazing opportunity to leave such a lasting impact in ways that hasn't been done before.
Just 500 miles from the North Pole, they've reached the ship's limit. All that lies ahead of them is an ocean covered in ice. This frozen world may seem barren, but beneath the ice lies a thriving underwater world where long-lived giants roam. Living up to 200 years, the bowhead whale has the longest lifespan of any mammal. And even more extraordinary, the Greenland shark, the longest living vertebrate, can survive for an astounding 500 years. Extreme creatures dominating an extreme world. The foundation of the whole ecosystem, ice. The team's first mission is to get beneath the ice and find evidence of the life that allows these Arctic giants to thrive. Former commando Aldo Kane starts the search.
The plan is that I want to dive under the ice. This is the furthest north I've ever been. This will be the coldest water dive I've done, the highest north dive I've ever done.
Aldo will be joined by underwater cinematographer David Reichart.
The plan will be that you and I go in, underneath, into the ice.
On the underside of the ice, Aldo and David hope to find algae, a critical first step in the Arctic food web.
The ice is closing in quite a bit round about us. 3, 2, 1. That's me in the water now, so we should push in under the ice and see what we can see. Over. Look at all the tiny little creatures in here. The water temperature is about minus 1.5 at the minute.
If you look into the light, you see this halo of these tiny little threads everywhere, which is the ice as it starts to form.
This is so cool.
Aldo, let's go take a look at this, kind of this zone over here. It's a little bit darker. Definitely indicates some kind of algae or something.
Yeah, David, that looks like some algae there, doesn't it?
But before Aldo can take a sample, the freezing water creates a big problem.
I'm having a freeze up, I'm coming up.
David's regulator has frozen.
David's having a free flow, we're coming up. We're coming up, we're coming up.
Now both their regulators are frozen open. The air is rushing from their tanks. It's an emergency situation. They have to abort the dive.
3, 2, 1, jump.
Both David and I jumped in. We thought we could see the algae, but David had a free flow frozen regulator, and I had a free flow frozen regulator. We were about here on the ice actually, so 5 or 6 meters in, and that's it, that's the end of the dive.
Aldo's found algae under the ice. Now deep sea researcher Zoleka takes the search for life to the next level.
It's too dangerous to take the piloted sub under the ice. So we are going to deploy the ROV to see what's down there.
The ROV is the ship's remotely operated vehicle, capable of diving to almost 20,000 feet.
Copy pod. Yo, look at them go. So tiny. It's great that we got this on camera, guys. Super great.
Zoleka and the ROV team have been able to find copepods, tiny shrimp-like creatures that punch well above their weight in the Arctic food chain.
They're the grazers of the algae under the ice.
Each spring, as algae starts to grow on the underside of the ice, billions of these quarter-inch long copepods rise from the depths to graze upon it. They in turn become food for many other ocean creatures.
It's really hard to conceptualize or imagine that the bowhead whales, one of the largest ever to roam the oceans, is feeding on this crustacean.
The team has found signs of life in these waters, and it all hangs on the ice. No ice, no algae. No algae, no copepods, no copepods, no bowhead whales. These bowhead whales can weigh up to 100 tons. Of all the animals on the planet, only the blue whale is heavier. Their massive head is up to 20 feet long and can create a breathing hole by smashing through solid ice up to 2 feet thick. Bowhead whales have a mouth so big you could drive a school bus into it. but they feast on the tiniest of creatures, scooping up almost 2 million copepods in every mouthful. Bowhead whales live across the Arctic with numbers in the tens of thousands. But here, the Spitsbergen population was hunted to near extinction. Their numbers were thought to be reduced to a few handfuls. In the 100 years since commercial whaling ended in the Arctic, the Spitsbergen bowheads have barely been seen or studied. The team's next mission is to find out how this population is doing now. Joining our team are marine mammal scientists Kit Kovacs and Christian Leidersen, who've been studying the polar region for over 40 years.
Bowheads in the Spitsbergen population are modestly famous in conservation terms because they were the first whale population in the world to be decimated.
Everything about bowhead biology is pretty slow and conservative. At more southerly latitudes, animals tend to live faster. They eat more quickly. They have babies more often. They have more babies in each pregnancy. Our Arctic animals, slow and steady is the rule.
These gentle giants like to take their time. They move slow. They breed late at 25 and have young just twice a decade.
Kit and Christian have this really cool piece of equipment that uses compressed air to fire a satellite tag into the skin of a whale while taking a biopsy sample at the same time. This thing's pretty cool, but we're gonna have to fire it from a moving helicopter. Finding these bowhead whales in the ice is not easy. Kit and Christian tell me it can take them 50 hours before they even find their first bowhead. So this is gonna take a long time, I think.
We want to go at 300 feet, around 60 knots.
Yep. What should I be looking for? I mean, are they usually in kind of amidst these chunks of ice? Are they usually in larger open spots?
That depends on what they're doing.
But everybody's looking for anything black, anything moving.
Anything you see actually looks suspicious.
Makes this extra challenging.
Always think positive.
Good advice, Kit. Thank you. So do they only survive, do they only live where there's the presence of ice on the surface, or do they venture further away where you can't find any ice?
They'll tiptoe out from the ice 100 to 200 kilometers for short periods in our area, but for the vast majority of their time, they're well into ice. Sometimes in what would be considered 100% ice cover.
Wow.
There's an animal at the surface here, right under us.
Oh yeah, I see it.
He's subsurface right now, but I can still see where he is. 11 o'clock.
This is happening.
2 of them.
2 of them?
9 o'clock. Yeah.
Good job. There's 3.
Positive thinking has paid off. 3 bowheads in one location.
Okay, let's get one of them.
Somebody coming in a little faster, we okay? Much lower.
70.
Much lower, is
60. 60.
He's coming. Come on, go down.
Great hit, Kristen.
The locator tag is successfully attached, but the biopsy sample needs to be scooped out of the water.
All right, we got it.
Kristen, are you ready for liquid nitrogen, please?
So you take off this?
Okay.
This tissue sample is precious. They quickly store it in liquid nitrogen.
Okay.
It's a huge win. And with another bowhead still at the surface, they have a chance to double down on the success.
I'm gonna come out from behind here. It's coming up again. Yes, he is. Just go down, go down, go down.
Yes, number 2.
There's another one right there. There's one right in front of us. Right in front of us.
40. 30.
You will come up again. Let's go closer, closer.
Okay, 3 deployed.
Tagging 3 bowheads in one helo mission is an extraordinary success.
We've been extremely lucky.
This is an amazing day.
We're out there in the middle of the nowhere, and we just hit the pot of gold.
Of course, I know this is just the beginning of where the science really happens, because now we have these biopsy samples.
In the ship's lab, Kit prepares the tissue sample from the bowhead whale for genetic analysis.
Here's our bowhead sample. This is our black treasure. The DNA these days is one of the most exciting analysis that you can perform.
Is this kind of similar to, like, if I do one of these things where I spit into a tube and send it into a genetic analysis place, they can tell me where my ancestors came from?
Exactly.
Just like a do-it-yourself ancestry kit, DNA samples will show how related these whales are. A small group that was taken to the brink of extinction, you'd expect a low genetic diversity.
Is it true they thought that this group of bowheads, there were fewer than 10?
I think between 1940 and 1980, there had been 3 sightings. So they suggested that it was a very tiny population. We thought they were all completely gone. But clearly, there were some individuals that had a strong preference and a very strong affiliation with sea ice. And they survived that really heavy period of exploitation.
That disposition probably was the thing that allowed them to survive through all this whaling.
No question about it, it was their saving grace.
Christian and Kit's research is showing a far larger and more genetically diverse group than we expected. They now estimate it could be as many as 350 bowheads. That's a lot more than a few handfuls. This Spitsbergen population must have survived out of the hunter's reach, protected by the ice. But the very thing that saved them, the ice, is now their new problem. It's disappearing. And fast. In the past 40 years, the amount of summer ice cover in the Arctic has shrunken by almost half. In just a fraction of the bowheads' long lives, their ice world has transformed around them. And it continues to shrink at an increasing rate.
It's changing quickly. It's changing so quickly, it's quite saddening. You know, by the time my son is my age, this environment won't be here. It won't look like this.
The team now wants to meet another giant, which also depends on the Arctic Ocean freezing every year. And incredibly, this one lives almost twice as long as a bowhead whale. So they travel to the islands of Svalbard, which is a known hotspot for the mysterious Greenland shark. These cold-loving giants are the only sharks to be found year-round in Arctic waters, feeding and scavenging on the fish and mammals that depend on the ice. Like the bowhead whale, the Greenland shark thrives in the icy water and is the longest living of all vertebrates, which means there could be Greenland sharks swimming in the Arctic today that were alive when the Mayflower sailed. But very little else is known about them.
These sharks are not very well studied. There's a number of reasons why not. One, they're deep sea sharks. Technology hasn't really been there before to understand them. And two, we're in the high Arctic. Just operating here is difficult.
the team's shark biologist, Melissa Marquez, is going to lead the mission to gather crucial data.
It's really hard to get access to Greenland sharks just because of how remote they are. Every single interaction that we have with these animals is extremely valuable. It's once-in-a-lifetime data that either is going to help validate the very little we know about these sharks, or it's going to cause a lot more questions with no answers, because this is a first.
We've teamed up with these scientists, Nigel and Eric, who are experts in this field. Maybe we can work together to unlock a mystery.
Hey, how's it going?
Hey, welcome to the Ocean Explorer.
Great meeting you.
Yeah, welcome aboard.
Pleased to meet you, Eric.
Welcome aboard.
We've come here to try and demystify or try and understand the Greenland shark.
The team gathers in the Mixed Reality Lab to share what little is known about these hard-to-study creatures.
So one of the coolest things I think that I find about these sharks is their age.
So they do hold the record as the longest lived vertebrate on the planet. The estimated age at the moment is 392 years, plus or minus 120 years.
So wait, that would be over 500 years old.
Yeah. The largest size confirmed for them is about 6.4 meters.
Wow, that's nearly 20 feet long.
Exactly.
They've got these kind of infamous eye parasites that make it a little bit hard to see, if not makes them blind.
Almost all Greenland sharks actually will have these eye parasites attached to their cornea. These sharks live often in deep waters where light is not very strong, and so they might not need to rely on vision as much as some other species. And so we think that they rely quite heavily on smell in order to find food and possibly to navigate as well.
It's probably remains one of the least known of all species on the planet. And what we really want to try and understand is what is the feeding behavior of Greenland sharks?
Working with Nigel and Eric, the team wants to attach motion sensors to the sharks to gather data on how they move underwater. This could offer valuable insight on how the sharks feed.
In this study, we're planning on putting some accelerometer tags on Greenland sharks. We'll be able to detect the number of tail movements, whether the shark is swimming up or down. Detecting those fine-scale behaviors, we're hoping that we can give us a bit more insight into the lives of these really mysterious animals.
The team hopes to attract the sharks from the icy depths by putting out baited lines.
What we'll do is we'll drop off an anchor first. Bait.
All right, first knot coming round. Clear. Mark position.
Marking that.
These conditions are perfect for tagging, so I actually hope we get a few sharks.
When we're tagging animals, we're thinking about doing the most humane way possible. We're thinking about the well-being of the animal. So with Greenland sharks, what we've actually got is a specialized hook that reduces injury.
Feeling good about it. Every so often there's a good tug.
It feels like we've got something on the line.
So I'm definitely feeling a tug.
So an actual like shark tug?
Yeah.
We might be lucky, we might be lucky.
Yeah, I can see it. Shark. Okay. Shark coming up. Looks big. There's a lot of weight on that.
This is a big animal.
Look at that tail. It's a massive, massive shark.
Ready, so that body strap.
Hold you.
You ready, Aldo?
Yeah, coming in.
Okay.
All right. Yeah. Whoa.
Yeah, no, it's it. It is strong when it moves.
Okay, it's a female, yeah.
Yep. So this is water activated, so as soon as it goes into the water?
Yeah, exactly. So I'll submerge it, and 10 seconds later, it'll start logging acceleration, also depth and temperature.
The motion tag will stay attached to the shark for 3 days, recording every detail of its movement, hundreds of times per second.
We ready for a measurement?
Yeah.
Okay, is she straight? Straighten her out?
Yeah. Yeah, perfect.
Perfect. Okay, 370.
370.
Yeah.
Good.
Dude, that's almost 4 meters.
Almost.
Okay, releasing from the middle. Body straps off. Okay, all clear of the red rope.
Okay, so it's gonna let it go, yeah.
Swimming away.
In the ship's lab, analysis of the Greenland shark tag data reveals intriguing results.
Each one of these peaks represents a full back and forth movement of the shark's tail. It took about 6 seconds for the shark to do one full back and forth motion, so quite slow. At certain points, the shark does increase its tail beat frequency, meaning it starts swimming faster. So what we're interested in is trying to figure out what it's doing during those times when it is exhibiting burst swimming or more rapid tail beats.
We can only predict that maybe is some response to stimuli. We need factual observations of what the animal is doing.
To find out what's causing this change in speed, Melissa sets up an experiment that could prove irresistible to Greenland sharks.
Oh, no!
They look fresh.
Don't even. We're going to be doing a food fall experiment. Essentially, we're going to put a bunch of bait down at the bottom of the ocean and see what shows up. Hopefully it's Greenland sharks. If Greenland sharks aren't attracted to this, I don't know what will.
To my knowledge, this is the first time that this type of experiment has been conducted.
Okay, she's going down.
The food fall experiment with these different sizes of prey basically allows us to see, okay, how firstly does the shark approach the prey? Secondly, when the animal actually takes the prey, does it consume it whole? Does it suck up the prey item? These are key questions we'd like to answer. The dinner bell's ringing.
Well, hopefully the sharks like this.
For their final mission, can the team be the first people to ever witness Greenland sharks feeding? 24 hours after sending the bait cage to the sea floor, Melissa and Nigel prepare to make the same journey in one of the ship's subs.
First time to get into a sub.
We just need to get down there, observe their behavior, see them in situ, and maybe see a little bit of feeding.
Ready to go.
Come on down, man.
Very exciting to go down underwater and go into the natural world of the Greenland sharks and see these animals behaving on this bait fall experiment. So we'll see what we see.
SO, Neptune venting now.
From Mission Control, Zoleka and Eric watch a live feed of the dive.
It's like a scuba dive, but without the contact from water. It's just surreal.
What depth are we at now?
180.
180 meters.
Oh, come on, sharks. We've got to see sharks. We have to see sharks.
The mission control team is also on watch.
My duty is to log any observations that we might see. For us to collect this data, this is really gonna take the whole understanding of the species to a whole new level. So it is quite something.
As they descend into the darkness, the sub-team has no idea if they will encounter Greenland sharks or what their reaction to the feast might be.
I got about 50 meters to the cage. There it is.
Oh, yeah.
I have cage inside,
There.
dead ahead.
Oh, no sharks.
I thought there would be something here, you know?
Just seems odd.
It's an unexpected start. The bait is untouched.
Oh, shark, shark!
Oh my word, that's just incredible.
He's gonna check out the cage.
Tail fin is hardly moving.
Oh, come on. You can smell it. I know you can smell it. Go for it. Oh, right on the nose.
This is not just a first for Nigel and Melissa. This is a first for science. No one has ever sat and watched a Greenland shark in its natural environment before.
Look, it's got the parasite on its eye.
Yeah, parasites on there. Navigated quite well around the front of the sub there.
Maybe he's as blind as he pretends to be.
The shark's behavior is totally unexpected. It's not going straight for the bait.
I've never seen that in another species of shark. Is it maybe because it can't see that well, if it bumps into it and it doesn't feel like what it would normally eat, it'd be like, nah, this isn't what I want, and it'll back up?
You know.
So even though it smells like it,
Yeah, but you would still think it would explore around. So I'm a little bit surprised.
Shark biologist Melissa has a plan to tempt Greenland sharks to the bait.
there's no current to kind of really help it out.
It's a very good point.
I think we've got to get in there and take some fish and go
I mean, I got a manipulator.
stir it up.
Turn it on hydraulics.
Give it a little shake. Yes, do that. Cause a little bit of a ruckus.
Think that's enough?
I mean, it's got a nice plume.
That looks like it smells.
Perfect. Come on, sharks.
Oh my word!
Male! It's just massive.
Here we go.
Look at his eyes.
That's like it's actually looking directly in us.
Oh my God.
Oh my goodness.
How can we go on the base?
Come on, come back around, baby. Eat something.
That.
Come on.
He wants it.
Yes. Yes.
Oh, there we go.
He's got it.
He's got it.
Pretty quick. I thought you said these guys were slow.
Killer instinct finally kicked in.
That is pretty strong movements there.
Exactly. It's almost pinning the bait down to open up this carcass.
That is incredible.
Oh, just look at it go.
This is brand new behavior. The team is making observations they could only have dreamed of.
To me, it's always like this conceptual idea with time,
Yeah.
with longevity. So we're looking at a behavior now in our time, but relative in their time, what does that mean?
We just saw what no one has seen before.
We have.
I call this a success.
I think we've done good.
To actually witness and see an animal that you've committed a huge amount of time, blood, sweat, and tears to studying it's indescribable how fabulous it is.
It's incredible. This is the first time anyone's ever seen a Greenland shark in situ like this and actually feeding.
The team meets to figure out the meaning of what they've just witnessed.
Is there anything that you guys have kind of seen with this data, with our observations, that you think might lend to them living so long?
The key in the data we've got here is, the fact that these animals live life in the slow lane. Maybe naively, I'd always thought that if I was a Greenland shark and somebody put a gold mine of food for me on the seabed, I wouldn't mess
Just
around.
dive into it.
Yeah, I would swim in
Binging.
there and consume, as much as possible. And it did the opposite. The Greenland shark came in and it patrolled, around the arena. It sort of, it checked us out. It was sort of surveying, its environment.
You kind of wonder about, does that have anything to do with how they manage risk? We're seeing something that lives a very long time, and I can't help but wonder if it's because they're so cautious that helps them not get into situations that cause them to die.
Yeah, that's a really good point.
Like most things in life, not everything has one answer or one solution, and it's probably a bit of everything, from the environment to metabolic rate to physiology. There's a million different factors that play in, but it's important to then at the end take a step back and realize that there's just so many factors going into it.
Yeah.
If in doubt, zoom out. Do you guys think then you've gained quite a lot of information and data?
Each one of these observations is like a gift for us to really get the gears turning.
He's like,
yeah.
So it's been a success then?
Yeah.
The combination of the team's efforts and the ship's incredible tech have allowed them to explore the high Arctic where few have gone before. They've gathered valuable data that's changed our understanding of a whole population of whales and captured unique footage of an elusive shark.
This mission has shown us just how much we still have to learn about these two amazing Arctic species. Their environment is changing so quickly, we're running out of time.
It's been great to be on this mission and being able to see these animals that are so hard to observe and live so long.
The Arctic is special and unique. There's a bit of magic here that you can't really find anywhere else.
Preserving the ice is the only way to keep life in balance here. We have to turn things around while we still have time. Not just for the future of these amazing ice giants, but for our future too. The ocean, the last frontier on Earth. So much is unexplored and unexplained. To change that, a kick-ass team of insanely talented specialists is setting out to push the frontiers of what we know about our oceans.
Oh my gosh.
Zoleka Philander, deep sea scientist.
Being a deep sea researcher means having front row tickets to the best movie that everybody wants to watch.
Melissa Marquez,
Straight ahead, 12 o'clock.
shark biologist.
We just saw what no one has seen before.
Eric Stackpole,
Scan now.
ocean tech innovator.
I love building tools that allow us to see things in ways we've never seen before.
And Aldo Kane,
This is insane.
former Royal Marines Special Ops.
It doesn't get any more cutting-edge exploration than this.
Their secret weapon, the Ocean Explorer. The most technologically advanced research vessel ever built. There's never been a more urgent need to understand our ocean and the animals that call it home, because their lives and ours depend on it. This time, we're on the trail of the Arctic's ultimate predator,
Go, go.
the polar bear. The Ocean Explorer is deep inside the Arctic Circle, in Svalbard. 400 miles north of Norway, it's wild, remote, and frozen. And Svalbard is home to around 300 polar bears.
Polar bears are actually considered marine mammals
Yeah.
on account of how much time they spend on the ice.
Yeah, extraordinary, really.
Polar bears have evolved to thrive on the ice, searching for pretty much one thing: seals. In one of the coldest places on the planet, calorie-rich seal blubber is the difference between life and death for a polar bear. But bears can only hunt seals when the sea is frozen. When the ice melts, seal season ends. The team is here in late summer. The sea ice is almost gone. Tough times for the polar bears. But recently, it's become a lot harder. Their ice kingdom is in danger, so the team needs to find out if they can survive.
The Arctic region is warming 4 times faster than any part in the world. And this is a huge problem for the polar bears because the summers are longer, and this means that there's not enough sea ice.
But that's just open water.
Yeah.
It's just wondering.
When there's no ice here, bears are forced to search for food on land.
It's hard to go here without thinking about change and how these pieces of ice are dwindling away.
And specifically is going to affect behavior of the polar bears.
With this environment changing so rapidly, the team's first mission is to find out if Svalbard's bears still have enough to eat. That means coming face to face with one of nature's most dangerous predators. Aldo leads the aerial team, with 2 experts who survey the bear's health each year.
Jon and Rolf are both working for the Norwegian Polar Institute up here in Svalbard. So they've got this study that's been going on for over 20 years now. What they're struggling to work out is how the climate is changing is having an effect on polar bears.
Almost every year, you know, they would have continuous sea ice down to the islands here. And as that part of the year gets shorter and shorter, it gets harder and harder to be a polar bear.
Jon needs to sedate and examine as many bears as possible.
Just go out to fjord a bit.
With climate changing, with the sea ice retreating further north, does that mean there will be less seals for the bears here to eat?
The main thing is the seals that are possible to catch.
Right.
They follow the coastline looking for bears that are on the prowl for food.
Do you see the fresh tracks down there in the night?
Yep. Bear. There's a bear down there. It's a big bear.
Rolf is a vet. His job is to dart the bear safely. The dart won't hurt the bear. It should put it to sleep in minutes, but it's not an exact science. He looks out cold, but they can't be sure. If he isn't fully sedated, he could easily kill Rolf and the team.
Yeah, he's fine. If you want to bring the
oxygen,
yeah, you bring that and you bring that there, yeah. And then I'll just. You want to put it on?
Yeah. Wow.
The blindfold protects its eyes and helps to keep it sedated while Rolf takes its vitals.
He's got deep, good breaths.
Beautiful. Just the muscle in these shoulders.
Try with your hands and compare with those.
Yeah. You can see just how specialized these are for the way they hunt.
They're very specialized at waiting at a breathing hole for a seal. It's got to catch it, drag it away.
Rolf thinks he's around 8 years old.
Quite a lot of the Dalton males, you see their broken teeth, fighting a lot. But this guy, he's got really nice teeth.
This is prime
He's in
age,
the prime
really.
of his life, really.
Yeah. Try to see. Oh, yeah.
By this point in late summer, there's been very little sea ice around Svalbard for almost 4 months.
He's a little bit thin.
He's a bit below average, I would say, yeah.
Yeah.
A blood sample will show whether this bear is eating seals or something else.
Each one of these tubes will be tested for something different.
Yeah, so you can get some indication about what they have eaten. If it's eaten mostly seals or more terrestrial food.
Starvation is the biggest cause of death for polar bears.
But what we suspect might happen is that where they've seen effects of sea ice loss, when things suddenly get worse, it will be the youngest and the oldest bears that will be affected first.
There he is. So that's him back on his feet now. He was under for just less than an hour. The guys have got all their measurements done now, given him the antidote to the anesthetic, so he's now back awake. He's standing there just for a few more minutes, probably just while he gets his bearings, and then he'll head off.
There's another bear that Yun is really worried about. A much older bear that he knows well. She's called Lyra. Yun first met her 9 years ago. As she emerged from her den with new cubs, he's been following her ever since. But the GPS collar that he fitted to keep track of Lyra stopped moving. It's a worrying sign. Her collar data shows that after a long summer with no sea ice, she spent 2 months walking almost 600 miles up and down the coastline. Yun believes she was searching for food. Then she stopped moving altogether. That was almost a year ago.
Should be somewhere here. Should be to the right here. Should be just underneath. So 20 meters now. About here.
Right. Oh, there you go.
Lyra didn't make it.
What's sad is that she had 2 small cubs when we captured her last autumn.
The cubs, you think, are dead also?
They are for sure dead. Because
If she
there's
died, then...
no way they could have survived without her.
The mortality rate is quite high then.
It's pretty high among juveniles, so maybe 2 out of 3, dies within a bit more than a year. Yeah.
Seeing a polar bear that's starved to death was really quite emotional for me. To think what she has gone through, losing her 2 cubs and wandering hundreds of miles looking for food. We hear about temperatures rising and ice melting, but this really brings it home when you see the fate of a family.
For the rest of the team, seeing the speed of change here is equally shocking.
The amount of sea ice that we're losing just from changes in the environment is greater than the amount of rainforest we're losing in the last 50 years.
Seeing this loss makes their mission even more urgent.
Climate change is not really something you can see. But here in Svalbard, you actually get to see it happening right in front of your eyes.
Aldo and the helicopter team push on. They need to find out if other polar bear cubs have survived with so little sea ice.
There's a bear. Yeah, that's a bear.
A mother and a cub.
Both bears are safely darted. The team has to work fast.
All good? She's okay? She's fine?
Yeah, she's fine.
Good condition?
She's not too bad, given that she has a small cub.
And the cub is...
doing well.
Yun's relieved to find a healthy family.
This one is good so well.
Is it a male cub?
Let's see. That's a male, yeah.
Yeah, male cub.
He will be 8 months. He was born about New Year's.
Yun knows this mother bear too. He first met her 7 years ago when she was just a cub herself. It's now her turn to try to keep her baby alive.
This cub will still be breastfeeding, is that right?
Yep.
I just checked that she have milk, so it's like white milk, so I just note that, which means she's still doing okay. Sometimes, you know, if they're really food stressed, they stop giving milk.
And that stress would come from the environment? Not
Yeah,
being able
from
to eat.
too little food, too little to eat.
Food, okay. And the cub is fine?
Yeah.
In fact, he's on the heavy side.
This guy's a little chubby.
Yeah.
There we go.
Weighing mom requires all hands on deck.
A bit more, so she's almost in the back. There.
Yeah.
Okay.
All right,
Oh,
she's off the
that works.
ground. Okay.
108.
She's 385 pounds. That means she's doing okay. Yun can now keep track of both mom and cub with her GPS collar.
She's starting to have some twitching.
Yeah, you got to be careful. Now is not the time to put fingers in her mouth.
Rolf clears her airway and makes sure she can't bite her own tongue as she comes around.
It's good to see them both back up and awake now.
Yeah.
It's great to see a well-fed mum and cub at this time of year. But with no seals to hunt, what are they eating?
The team's second mission is to investigate if these bears are adapting to hunt new prey.
So polar bears have always been adaptive. They're opportunistic, they always have been. But there isn't much else in Svalbard and around Svalbard for them to eat. So we need to figure out if they're switching to eat something else.
Eric's up first. He's on the trail of an animal that could be filling the seal gap. Walrus.
So walruses can weigh over 1,000 pounds, and they have this thick, blubbery layer, just like seals. Could that be what the bears are eating? That's what I want to find out.
With wildlife cinematographer David and polar safety guide Tom, Eric heads for the walrus haulout.
If we do see a bear in the area, if either of you see anything that looks like a bear, tell me straight away. If I see a bear, I'll let you know, but the first thing we're going to do if there is a bear in the area is we're going to get back on the boat.
Okay. Some sort of animal poop. Oh yeah, look at that. Well, that's, you know what that is?
I mean, it's sizable.
I know, it's kind of a big animal.
I mean, it's not walrus poop.
No.
And it's not fox poop.
No,
It's
too
it
big
has
for that.
fur in it as well. I mean, so that means it's a carnivore's poop. I mean,
this could be polar bear poop.
Yeah. Yeah.
They've been here.
Yeah.
Okay.
Something's been in this area.
All right, well, the evidence is surmounting that perhaps...
We've got bears.
We've got bears.
As they inch closer, they get a polar bear's eye view of the walrus colony. They've been spotted.
All right.
Don't move.
Look at the size of them.
They beat a hasty retreat. By the time they reach the boat, they're not alone.
They're pretty curious. We might actually want to push off right now.
Yeah?
Yeah.
All right.
They're sluggish on land, but in the water, that is their turf, and they know how to handle themselves in it. So they could be very, very dangerous, especially to a boat like this, where, you know, if they got aggressive with the boat, it could puncture the hull. This is an inflatable boat. So these are these moments where you don't really know what nature's gonna do.
We're done. We're gonna get out of here.
All right, we gotta go.
Yeah.
One encounter is not definitive, but it seems very unlikely to me that a bear of any size is going to be able to attack a fully grown adult walrus.
On the other side of Svalbard, the helicopter team is also looking for clues.
It really does boil life down into the absolute basics of wandering around a barren wilderness looking for your next meal.
Absolutely.
These bears are definitely eating something substantial.
He is fat.
Yeah, super fat.
They spot a clue.
Oh, is there some sort of carcass down there? Just in front of you, 12 o'clock.
There's something here.
That is a reindeer carcass.
Look at that.
There's another carcass there, look.
Yeah, this is interesting.
Yun has only ever seen bears scavenge dead reindeer.
Reindeer up here.
A lot of reindeer here.
It's not long before they see the evidence they're looking for.
There was
a bear on the hill right this side of the.
Oh yeah, yep.
Okay.
He's on the move.
Yeah.
He looks fat.
It's very nice condition.
Yeah.
He's sort of stalking up these little valleys to where the reindeer are.
Perfect terrain for reindeer ambush.
That's the thing with the bears, they're not really evolved for running or for that sort of predation, but I guess if the terrain suits, that's just like classic ambush country.
Exactly. Yeah, it is.
It was thought that polar bears couldn't outrun something as fast as a reindeer, but they're using the terrain to their advantage. As a sniper, it's my job to close the distance to the target using cover, and that's exactly what the bear's doing before it uses a final burst of speed.
It seems that some of Svalbard's polar bears have found ways to hunt new species in the long summer months. A possible lifeline as their home gets warmer.
So that's very interesting. Professional reindeer hunter.
Yep.
Analysis of the blood Yun's taken from the sedated bears tells him exactly what they've been eating. Bears here are now consuming a higher proportion of land-based prey than before.
So I guess with it becoming warmer up here and less sea ice, they have to adapt their behavior and their hunting strategy.
So there is a couple of things we've seen studying these local Svalbard bears is that bears use much more time on land And we also get evidence that reindeer actually are taken by polar bears. Like what we saw, you know, the reindeer carcass.
Mission accomplished. The team has witnessed the evidence for themselves that polar bears might be able to adapt and survive in a warming climate. It's a Hollywood ending. But nature doesn't do Hollywood endings. Polar bears in their prime might be able to switch from seals to reindeer. But for newborn cubs, that's just not an option. Polar bear cubs are totally dependent on their mother's milk. Mom gives birth in winter and keeps her cubs in the den for the first 3 months while she nurses them. When they all emerge in spring, she's running on empty, and her cubs need solid food. Her salvation comes in the form of a unique frozen hunting ground, found at the base of Svalbard's massive glacial cliffs.
Glaciers are an accumulation of snowfall over thousands of years, and this forms a huge ice sheet. Where that ice meets the ocean, it gives the sea ice a solid structure to latch onto. And it's the sea ice that's vital for polar bear moms in spring. It's where the seals have their pups. For a starving polar bear mom, these seals are the difference between life and death.
These feeding grounds depend on glaciers like this reaching the ocean. And there's the problem. Svalbard's glaciers are melting fast. If glaciers retreat onto land, the sea ice no longer has a strong anchor. It breaks up and drifts away, taking the seals with it. Nearly a fifth of Svalbard's glaciers have now retreated onto land. If this trend continues, do polar bears even have a future here? For their final and most important mission, the team wants to answer the question: how fast are these glaciers retreating? The Ocean Explorer has arrived at the largest glacier in Svalbard, Austfjord. This 3,000 square mile slab of ice is 10 times bigger than New York City. Every summer, meltwater pours off it. And as the temperatures increase, these waterfalls are expected to get bigger. Are these uncontrolled rivers melting the glacier faster? The team brings in top ice scientist Andreas Alexander.
Andreas Alexander is a glacial scientist. He studies the way that glaciers are changing over time, and he's been doing this for many years. So he's an expert in all the subtle ways that glacier movement may be affecting the environment around it.
Melissa Marquez will also be helping Andreas on this mission.
Glaciers are changing up here very, very fast.
Yeah.
They're melting, and every year we get more melt. What is happening at the edge where the ice meets the ocean. We don't know how much water actually is flowing through this channel. How fast is the water flowing? At what temperature is it? And a big challenge that we are facing is we can't measure it. Lucky number 7.
But Andreas hopes to change that with a new piece of tech.
Oh my gosh.
This is a drifter.
There you go.
The plan is to drop it into a river 10 miles inland on the glacier. It will travel down the rapids, recording the water speed and pressure on the ice. Finally, if the drifter makes it to the front of the glacier, it'll tell us how much these rivers and waterfalls are influencing the rate of retreat.
For us to be able to gather any information from these drifters, they have to be deployed upstream enough so that they'll follow the stream for enough distance to collect good data and then go over the waterfall into the ocean.
No easy task. How do you get to the headwaters of a glacier? You walk. The rivers form a dangerous maze. One wrong step and you risk broken bones or worse.
Some rapids there.
Yeah. That's
big.
a big one.
Whenever you're ready. 3, 2, 1. Yeah, here we go. And let's get out of this.
Go, go.
Nice one. Heck index, yeah.
Stand on those toes. There you go, good work.
After 10 miles of trekking, they've reached a suitable deployment spot, a river big enough to go all the way to the front of the glacier.
I'm just letting the boat know that we've got these 2 drifters that we're about to send out. And I've gone ahead, sent the GPS coordinates.
Then we are ready to deploy, huh? And wish it the best.
All right.
Wish it good luck.
Good luck.
Okay, 3, 2, 1, and off you go. 3, 2, 1.
2 drifters are away. Waiting on the ocean, Eric and Zoleka have the difficult task of finding the drifters, if they've survived the rapids.
You can scan now. We're just waiting for this terminal to show a signal. I haven't heard anything yet, nothing yet. Oh, we got one, we got one. Yeah, we got one. It should be off our port bow somewhere if we think it's close to the glacier.
Oh my gosh, the swell is not helping. I can see it. My 12 o'clock. I've got eyes on it.
Both devices have made it out of the glacier, but they've landed in dangerous waters.
Oh, coughing just happened. Oh my gosh.
So what's the plan here?
We're gonna do a drive-by, try and pick it up.
Got it. I mean, look at this. The whole glacier is disintegrating as we're up to it. We really have to be careful here. He's got it. He's got it. He's got it. Great job. Okay, we're ready for number 2 if you're able to get that out. 2 of them in.
For the very first time, Andreas's drifters have been successfully retrieved from the ocean after a glacier deployment. In the ship's mixed reality lab, the team is eager to see what secrets they reveal.
This basically shows what it looks like just below the waterfall when it reaches the ocean.
Glaciers with no waterfalls are insulated by a layer of calm, cold water at their base, so they melt very slowly. But here on Ostfana, the drifter data reveals a different picture altogether.
But what we see now is you have the fresh water coming in, and that fresh water destroys this isolation layer of the cold water. What that will do, it will create heat, and that heat is what's melting, what's driving the melt. But it's the combination of warmer ocean water and then the fresh water hitting in, creating the currents, and those currents are the ones that drive the ice melt.
Scientists had expected this glacier to retreat at least 130 feet a year. But from the new drifter data, Andreas has calculated around each waterfall, the rate of retreat could double. And that's bad news for polar bear moms. They need glaciers to reach the ocean so that sea ice can anchor to them and make a stable hunting platform. This revelation is bittersweet for the team.
It's this really big sense of achievement that we've got brand new data on how quickly these glaciers are melting. But what it's telling us, well, that makes me really worried for polar bears. If the climate keeps warming, is there a limit to how much more they can adapt?
We've seen that some of them can adapt, but is it enough with the world changing so quickly?
This isn't just about polar bears. So much of the Arctic is teeming with life. It drives ocean currents, it moderates our climate. So much depends on it.
But the team has hope for the future.
If the world keeps to its promise and limits temperature rise to 1.5 degrees Celsius, there should still be an ice kingdom for polar bears.
Svalbard's polar bears are just about hanging in there for now. But for them to have a real future, that's on us. The ocean, the last frontier on Earth. So much is unexplored and unexplained. To change that, a kick-ass team of insanely talented specialists is setting out to push the frontiers of what we know about our oceans.
Oh my gosh.
Zoleka Philander, deep sea scientist.
Being a deep sea researcher means having front row tickets to the best movie that everybody wants to watch.
Melissa Marquez,
Straight ahead, 12 o'clock.
shark biologist.
We just saw what no one has seen before.
Eric Stackpole,
Scan now.
ocean tech innovator.
I love building tools that allow us to see things in ways we've never seen before.
And Aldo Kane,
This is insane.
former Royal Marine Special Ops.
It doesn't get any more cutting edge exploration than this.
Their secret weapon? The Ocean Explorer. The most technologically advanced research vessel ever built. There's never been a more urgent need to understand our ocean and the animals that call it home. Because their lives and ours depend on it. This time, the team is among the giants of the ocean.
I could not believe that we were watching this Fight Club.
They face an unexpected encounter.
Oh my God. I can't believe I'm seeing this!
The Ocean Explorer is in the Dominican Republic, in the Caribbean. It's heading 50 miles off the island's north coast to an area of the Atlantic Ocean teeming with giants. humpback whales.
Humpbacks are one of the largest whales on the planet. They're about 45 feet long, and that's the size of a school bus.
We almost hunted these whales to extinction, but thanks to the global efforts to bring them back from the brink just over 50 years ago, these whales are now thriving.
Every winter, thousands of humpbacks migrate to these waters to mate and give birth. But as they spend the majority of their time beneath the waves, details of their lives remain a mystery. That's why the team is here, to uncover secrets of these whales in some of the most intimate moments of their lives.
Okay, come in.
For this mission,
All set? Cool.
the team will need to draw on the full capabilities of the ship.
Zoom out a bit.
The ship is incredible. We have a helicopter, we have a deep sea ROV, we have 2 submersibles. Any question that we would want to answer about the humpback whale seems to be answerable with the technology and resources we have available.
We know that humpback whales travel up to 5,000 miles from their feeding grounds in the North Atlantic to this small patch of ocean, and that they come here to breed. But how exactly does a female humpback choose her mate? To find out, Eric's job is to first spot the whales,
Gavin, you can power up.
then guide in Aldo and the dive team to get a rare underwater perspective.
All right, Captain, good to go.
Not so easy.
Green light, green deck.
Copy. Green light, green deck. Let's go find some whales.
Chopper is off. Chopper is off.
The conditions are perfect. You could not ask for a better day to be searching for whales. The water is extremely calm, so anything that comes up to the surface of the water, we should be able to see.
Oh my God, there are whales everywhere. Oh wow, that is really cool.
With eyes in the sky, it doesn't take long
Oh, look at this.
to spot some courtship action. There's a single adult female surrounded by males. Peaceful gatherings like these can suddenly erupt, turning into a frenzied pursuit.
Whoa, what was that move all about?
The female is leading the pack. She has a suitor, and he's following right behind her.
Female's speeding up.
If he loses his position, the chance to mate with her will be up for grabs.
Whoa, is it pushing that one out of the water?
Yeah.
It's pushing it out of the water. Oh my gosh. Whitewater everywhere.
No wonder some scientists call this a fight club.
I mean, there's just so much muscle and energy in that. I mean, each of these weigh more than a truck, you know, and they're pounding against each other, speeding through the water. I cannot believe that we were watching this fight club, like, right below us.
Mike Delta, Mike Delta.
This is Eagle Ray.
Eagle Ray, this is Mike Delta. We're watching, we've counted 11 whales in this group.
They've generally been holding the same direction. Yeah, roger that. Once we get on location,
We'll try and get in the water if it's safe to do so.
This is definitely a sprint, and it's going to be survival of the fittest.
Order that out.
If former Special Ops Aldo and cameraman David can get in the water with the whales, they may be able to record behavior that's invisible from the surface.
Have you been in the water with 11 whales before?
Only once before was I ever in a group this big.
Yeah.
So it's pretty violent, in fact, for the whales, and so we just got to be careful where we are.
Every time I get in the water with big animals, I am apprehensive, you know this?
Yeah.
We are in their territory, in their environment, and we are tiny in comparison. If you get on the wrong side of one of those neck fin slaps or a tail slap, then it's going to be game over.
Yeah. Let's try and get in ahead of them. Yeah, absolutely.
Oh, look at that quick turn. The whole group just turned 90 degrees.
Like that.
They're turning away. You missed it.
All right, I'm scanning around for anything else.
There's a big group, 3 o'clock.
Yeah, there's something. All right, go check these guys out. Devil Ray, Mike Delta. We're moving over to some breaching whales. That's the direction we're going now.
Copy that.
There are more males around a female, but this group appears more relaxed.
You may want to try to get in the water here.
With very little known about the whales' courtship rituals, Aldo is concerned that any bubbles could spook the animals. So they're diving without tanks.
Freediving is the closest that you can become to being a mammal in that environment. On one breath, you can dive down and be in their world.
Holding his breath, Aldo swims to a depth of 70 feet. These whales seem totally at ease with their visitors. There's a female surrounded by 5 males. The mood couldn't be more different from the Fight Club. She wants the fittest father for her calf. But how will she choose him? One male moves closer. He gently blows a stream of bubbles onto her belly. An encounter this intimate has rarely been seen. We need to try and understand what's going on.
That has to be one of the best experiences I've ever had. Like when they cruise underneath you, it's literally like having a small plane underneath you. We can take those shots back and show
some of the scientists on board, they can look at behavior, they can maybe tell us what those whales were doing in that social circumstance.
Hey, Eric, I've got some cool stuff for you to look at.
The footage will be analyzed by whale scientist Asha de Vos.
The more we observe and the more we document, we can start to actually understand it from the viewpoint of the whale. And I think that's what's really interesting and unique for us.
Devil Ray, Mike Delta.
For the next week, Asha joins the dive team. Their aim?
Oh, 3!
To collect as much footage as possible
Hey, whale, dead ahead!
of as many courtship groups as they can find.
Yeah, we just saw it split because it went down.
Very little is known about a female's mate selection, but by going through every frame,
I hope you're as excited as I am about what we found.
Yeah, I am too.
Asha's made some observations about the female that Aldo dived with.
We know this is a female, and you can see her tail is very characteristic. I call her asymmetrical because it's not a symmetrical pattern. She's, clearly rolling around, displaying herself. We see this very intimate moment where they're hanging. They're not moving much. And for about 15 minutes, they just stayed in one place, like this. You feel like a really strong bond. Then you're thinking, this can only lead to mating. We find another group of 6. If you look carefully, see, that's her tail. Remember, asymmetrical. I don't recognize any of the other males in the group, so she's found a complete new group of guys.
But I don't understand. She already found her mate.
Well, that's what we thought. She does similar things. She rotates, she does these really intimate movements. And then we find a group of 11 animals, an amazing moment. And then we start seeing this peck slapping event going on. And this peck belongs to the same female we saw in the previous 2 encounters. She has slipped from one group to the other.
This is more like dating, and the relationships just aren't quite working out, but she's still trying to find the one.
Yeah, she wants a nice, strong calf that can survive into, the future, and she's gonna take her time.
I have to look at this kind of like online dating, swiping away and trying to find, Mr. Right swipe.
Yeah, exactly. And in the short time we've been here, we now have a little intimate peek into the life of this little lady and how she's chosen to maximize her time here on the mating grounds.
We don't know if this female mates with any of the males or carries on looking for the perfect match. But in this rare footage, the team has observed just how choosy a female humpback can be. And there's still so much more to learn. Off the Dominican Republic, the humpback breeding season is in full swing. But why do the whales come to this specific patch in the North Atlantic every year? To find an answer, the team is going to focus on another humpback behavior. We know that for adult males, it's important to sing during mating season. And they do this often, and for hours at a time. The team wants to test a hypothesis that the unique underwater landscape here could provide an advantage for the singing males. Leading the mission is deep-sea scientist Zaleka. Armed with detailed bathymetry,
Hi, Dave.
Hi.
she'll be diving to a depth of 250 feet.
The Ocean Explorer has mapped the seafloor, and it's revealing a hidden underwater world. There are these great mountains rising to up to 2,000 feet, and these are topped with a plateau that stops just below the surface. So these plateaus have bowl-shaped edges on the wall, which are around the size of a football stadium, and these are what we are interested in.
Okay, team, here we go.
Okay.
Zuleka is joined by marine mammal scientist Mithriel Mackay. From her aerial surveys, Mithriel has developed an intriguing hypothesis.
We could see whales tucked into these half circles. They remind me of an amphitheater. Is it possible that they're using these to do something with the song to make their song easier to hear, or maybe farther to hear, or louder for other whales? And so we started getting into this whole hypothesis of whales are using the amphitheaters, these features out here, to sing in order to broadcast their sound better for other humpback whales. And that could be a way to improve their chances of finding a mate. I saw something right above us, just like a flash. It was really strange.
I can hear whales. 100%. 100%. Oh my God.
I'm really excited to see if Mithriel's hypothesis is correct. In order to test it, our plan is to set up a series of microphones within the bowl, both deep and shallow, to record sound waves.
Okay, where do you want it?
Try right there. Yeah, we're both looking right in that same patch right there.
Using the sub's robotic arm, they carefully place the deeper microphones around the sides of the bowl.
Very nice.
Testing the amphitheater hypothesis. This is exciting, hey?
It's very exciting.
Directly above them,
All right, I've turned 4 on in the bucket on my side.
Eric and acoustic scientist Carrie Sager are setting the shallower mics.
So this is the actual part. All of the work is being done by this little bit here. That's
Right.
the hydrophone. This is going to be listening to that sound reverberating off the amphitheater.
Right.
All right, here's the hydrophone.
All right, hydrophone in. Ready to mark.
Ready to mark.
Number 11 in water.
Number 11, waypoint mark.
A waterproof speaker will play Humpback Song.
So the plan is that this is going to be about the same depth that a male humpback whale will sing at.
Okay, and starting.
All righty.
Waypoint marked.
And we're not going to hear it. Oh, we do
We
hear
can
it.
hear it. Oh my gosh.
All the microphones, both shallow and deep, will register the volume of the whale song recording. Then it's back to the ship to find out the results. The acoustic data has been processed
That's very exciting.
and can now be visualized in the ship's state-of-the-art HoloLab.
The HoloLens, of all the different pieces of equipment on this ship, is the most futuristic. It feels like living in a science fiction movie, where it's like you are interacting with an imaginary world, like something that's inside of your head, but you can show it to everyone else. This is a great tool for helping visualize and communicate with others.
It looks like we've gotten some results. Carrie, what have you seen?
The first thing we're going to see is the very first sound signal coming from speaker A. Exactly what we would expect from a sound wave moving away from the wall. The orange is a little quieter, yellow's quieter than that, and then green is, the quietest. Now we're going to add in the echo from the wall and see if it amplifies these numbers. So here's our echo, coming right off the wall, and boom, boom, boom. Look at the added intensity there. So everything's red, everything's in the 90 decibels. Like 10, 11 decibels, that's a huge amount of extra sound energy in the system.
11 decibels, that's like a multiple.
So now we know the benefit is that they could get that sound to be louder and behind them and reach more whales. This is pretty cool to see that, we've uncovered something that's going on here.
Mithriel and Carrie now have proof of concept that the bowl-like features really do amplify a whale's song by as much as 11 decibels. This could be one reason why so many whales come here.
Just absolutely groundbreaking and huge, and a culmination of so many years of my work that it doesn't really get more satisfying than that.
It seems that the underwater terrain is providing an advantage for humpbacks seeking a mate. But it's not just whales looking to breed that come here. Females that became pregnant here last year have returned to give birth and to rear their calves. The warm shallows which lie above the submerged mountaintops provide the perfect nursery. These waters are believed to be the main reason why a humpback mother travels up to 5,000 miles to raise her young.
This is a very important place. It's not just that the calves are born, but they're taught life skills. This is a big schoolyard. This is where they also come to teach their young how do you survive if there are predators around. So they don't have a lot of time to teach those life skills before they have to basically pack up their bags and take this long migration all the way back to the North Atlantic.
If whale scientist Asha and cameraman David can get an underwater perspective, they may be able to capture a rare glimpse of the intimate bond between mother and calf. They approach the mother and calf slowly, and the pair seem undisturbed. Only the females are involved in parenting. This is mom's time to pour all her energy into her single calf. Just a few weeks old, the calf bonds with its mother through touch. Only able to hold its breath for a few minutes, the calf stays with the mom near the surface. It's entirely dependent on her, guzzling 50 gallons of her rich milk every day. There's no food for mom here. She hasn't eaten for 5 months. But she must continue to nurse her calf until it's strong enough to survive the journey to their feeding grounds.
The calf clearly got curious, came to see what this other little object in the water was. All kids are curious. All kids are like, what is that new thing? But then, you know, a mother's instinct is to make sure that she's protecting that calf. So Mama was like, you know what? Not right now. And she just, you know, she did a U-turn underwater, and I guess the calf knew immediately it was time to leave.
Yeah, it was a good protective mother. For the survival of their calves, they need to be very protective. Life for these young whales just to survive, to make it through that first year. To get to be an adult humpback is not easy.
In the nursery grounds, mothers and calves are relatively safe. But when they enter deeper waters, what dangers does a young humpback face? To find out, the team now plans to tag a mother and a calf as they start their migration north. It's down to Eric to find a mother and calf on the move and guide in Aldo and the tagging team.
Okay, here we go again.
Looks that straight ahead. Definitely a blow and some action.
Oh, yeah, I see that.
This pair have left the nursery grounds. For the hungry mother, timing their departure is a life or death decision.
Ocean Explorer, this is Mike Delta.
Mike Delta, send. Hey guys, we are seeing what appears to be a mother and calf. You may want to take a look at them.
Yeah, roger that, thank you. Out. So we're going out to put these tags on. They have cameras, temperature, depth, acceleration sensors. So with these, we're definitely going to get some good scientific data.
There's something else in the water, just forward of that.
orca,
Oh, wow.
also known as killer whales. These are the ocean's apex predators. It's a family of adults and juveniles. They need to eat, and they're heading straight for the mother and calf.
Oh my God, steamed in there. They're like wolves, they're surrounding the thing.
Look at that. She's keeping the calf on her back to keep it from being attacked from underneath. Its belly is the most vulnerable spot.
The baby just went off the side, it's trying to get back.
Nobody's ever filmed this here. This is so tough to watch. I mean, these orcas are relentless. But we've got a chance here to understand how mom defends her calf. And these orcas are some of the most intelligent creatures on the planet. This is giving us a chance to see how they organize their attack.
What a horrible situation to be in. I mean, it's just, I can just picture the emotions this mom has. Look at that. Magnificent and terrifying.
Mithriel changes the plan on the fly.
Can you see flippers on the surface?
Dead ahead, 400 meters.
She now wants to tag an orca. It could give the team the first ever scientific insight of a hunt in these waters. Carrie is in charge of tag deployment.
I see flippers. It's resting underwater, 100 meters, below.
For everyone's safety, including the animals, timing is critical.
Everyone set?
All right, you guys, I'm ready to tag whenever you're comfortable.
The tag's 4 suction cups will attach to the orca without hurting it. They'll release after 12 hours,
Yeah, okay, we're ready to tag.
if they can get the tag on.
Killer whale coming this way.
Let's let it go under. Let's let it go under.
Whoa, look at the size of it.
Killer whale underneath us.
Yeah, killer whale underneath.
I got one right up front. Killer whale's coming up. Killer whale's under my tag.
Tag on!
They've tagged the lead female. And she's with some pregnant females who need to eat for 2. And juveniles who need to learn to hunt. This is a battle between 2 families.
Oh, wow.
These strikes aren't risk-free for the orca. To protect their vulnerable lower jaw, they hit with the top of their heads.
To see it this close is brutal.
Everybody's got to eat, and that's something that a lot of people forget. It's important to remember that there's a balance here. They're doing what they do best.
The orca appear to be coordinating their attack. Their strategy to separate the calf from its mother. Hold it down and drown it.
Looks like this is a long fight. Mom's a formidable opponent. I mean, she's got pectoral fins that are 15 feet long, and those are covered in sharp barnacles. She's not giving up.
The orca's hunting calls can travel up to 9 miles through water. And they've been heard. Another group arrives.
I've heard about this happening, that sometimes 2 orca groups can come together for a kill.
Oh my gosh.
Oh my god.
Those are reinforcements.
They are everywhere.
All right, we've now got 2 humpbacks against 18 orca. Oh, poor Mom has got to be exhausted, and this is all happening. I mean, how long can she go?
So they're just wearing the calf and the mother down, aren't they? It's just like a battle of attrition, isn't it?
It seems to be reaching a breaking point.
The orca finally succeed in isolating the calf, and they drown it. This calf will feed the orca family. Studies suggest that other whale species grieve at the death of a calf. Maybe humpbacks do too.
What we saw today has never been seen, not with the kind of view that we just had. I'm still taking it in, honestly. Like, I feel emotionally exhausted.
All the footage from the hunt has been studied in fine detail, and the team is gathering in the ship's HoloLab where Mithriel can share their findings.
When I started to look at the still photos I took from the boat and the video footage from the helicopter, it looked from the surface that the orca had a simple strategy, and that's to pursue the mother and the calf until the point of exhaustion. But once I looked beneath the waves, with the tag video, it became clear just how complex and how coordinated their strategies actually are.
Mithriel, you've been able to sort of decipher what was really going on here.
What I realized is we have something really organized. The alpha male was part of the group on the outside. Their main job was to keep Mom moving and tire her out.
So the alpha male moves into position.
So he did what we're calling a fluke clap. It's actually cupping that tail, slapping it against the water. That appears to initiate some kind of signal communication within the group.
Mithriel believes the fluke clap is a signal to 2 of the orca to swim in front of the mother humpback, forcing her to slow down. The next play comes from the lead female.
She does a hit. She comes up over Mom's back, hits the calf, knocks the calf off Mom's back. Mom comes down. She takes a swift dive down and puts her flippers way out and picks up that calf back in the water again, recovers the calf.
Mithriel's analysis is that by working together, the orca can maintain a relentless attack, constantly forcing the mother to recover her calf.
The way she did this over and over and over again really made me think this has to be a mother humpback whale that's had experience. We got a picture underneath her tail. We submitted that to the catalog. This mom was sighted 1992 and 1993. She's at least 30 years old. This was not the first time she's had to deal with this. And she did a great job of recovering that calf over and over.
At this age, the mother may have had 9 or 10 calves. Some will have become mothers themselves, returning here to raise their own calves. Here in the Dominican Republic, with the tools of the Ocean Explorer, the team have made breakthroughs
That's very exciting.
in understanding the secret lives of these humpbacks.
Oh my gosh! I cannot believe that we were watching this fight club like right below us.
They may even have figured out why the whales come here.
Boom, boom. There's absolutely nothing more rewarding than doing new science and finding answers.
They've captured new details in the mating rituals of these giants.
I was freediving with the 6 big whales, and you're in their world. They're doing courtship maneuvers. From my point of view, it's been amazing. Tag on!
But their greatest revelation comes from their surprise encounter, shining new light on the battle tactics between humpbacks and orca.
For me, every single day has been a revelation. It's overwhelming, to be frank.
The team's discoveries will be shared with scientists around the world,
This is just a gold mine.
increasing our understanding of humpback whales. The better we know these incredible creatures, the more we can ensure they continue to thrive. The ocean, the last frontier on Earth. So much is unexplored and unexplained. To change that, a kick-ass team of insanely talented specialists is setting out to push the frontiers of what we know about our oceans.
Oh my gosh.
Zoleka Philander, deep-sea scientist.
Being a deep sea researcher means having front row tickets to the best movie that everybody wants to watch.
Melissa Marquez,
Straight ahead, 12 o'clock.
shark biologist.
We just saw what no one has seen before.
Eric Stackpole,
Scan now.
ocean tech innovator.
I love building tools that allow us to see things in ways we've never seen before.
And Aldo Kane,
This is insane.
former Royal Marines Special Ops.
It doesn't get any more cutting-edge exploration than this.
Their secret weapon, the Ocean Explorer. The most technologically advanced research vessel ever built. There's never been a more urgent need to understand our ocean and the animals that call it home. Because their lives and ours depend on it.
Okay, here we go. 2 o'clock, 2 o'clock.
This time, the team tracks sperm whales down into an alien world
What is that?
full of fantastical creatures. The Ocean Explorer is heading for deep water, just off the Azores, a chain of tiny volcanic islands in the middle of the Atlantic, and a rich oasis for an abundance of marine life. Every summer, nearly 1,000 sperm whales gather here. They're easily identified by their distinctive sideways spout. These whales spend most of their lives deep below the surface. But using the full scope of the Ocean Explorer's tech, the team hopes to shine a light on their lives down in these black depths.
Stand by 9 o'clock.
Sperm whales were hunted here as recently as 1987, and they live up to 70 years, so some of them may still remember that. They're understandably nervous around boats, so Aldo and Melissa approach cautiously.
You got your eyes on them? They're sneaky, I tell you. Oh my God, they're right underneath us. They're right underneath us.
Wow, look at that. It's a whole family pod.
That's gorgeous.
That is a first for me.
Yeah.
Sperm whales are the largest toothed predator on the planet. To study these giants up close and personal, Aldo and Melissa join them beneath the waves.
Getting under the water and just seeing this giant animal, you can feel it looking at you, trying to figure out what the heck you are.
But they won't have long. Sperm whales spend just 20% of their lives at the surface.
When they dive, it's phenomenal.
One swoosh of their tail and they are gone.
These whales are diving a mile deep for up to an hour at a time. The buoyancy of their huge lungs and the thick blubber should make that almost impossible. But not only do they manage it, they make it look effortless. But exactly how they dive so deep has never been filmed. If the team can get a camera on a whale, it could further their understanding. They recruit the help of Rui Prieto. A world-leading whale biologist, he's been studying them in the Azores for over 20 years.
We want to see what they are actually doing while they are underwater.
Eric sets to work helping Rui build a camera tag that can withstand the immense pressure of a sperm whale dive.
Okay, so this is the power system. And then we've just got the little camera. You know, the whole thing looks pretty simple, but I mean, the thing that keeps going through my mind is, you know, we're gonna have, you know, maybe one window and one chance of putting this together the right way.
So, do you think that's something we can do?
Fingers crossed, right? I guess we'll find out.
If they can pull this off, they'll get the first ever footage of a deep sperm whale dive in the Azores.
Yeah. Let's turn a whale into a cameraman.
You have a green light. Copy, green light. Your deck, we're off.
We need to start looking for blows.
Yeah.
Well, it looks like there could be something over there. 4, 5, 6, 7, 8, 9, 10. I count 11 whales here, all in a tight cluster. Okay, here we go. 2 o'clock, you should have a pretty good eye, 300, 400 meters.
Breaching!
No! We think breaching might be a form of communication between a sperm whale family. However, sometimes it might just be the teenagers fooling around and, blowing off some steam.
Let's go there very slowly. Slow and steady wins the race.
Is that speed okay?
Need to gain a little bit on them because they are almost diving.
When you're piloting a boat this close to whales, there's absolutely no room for error. You're dealing with a live animal, so the whole thing has to be 110% perfect, or it's an aborted mission.
That's it.
Well done. Well done, dude. Tag on. Ocean Explorer, this is Eagle Ray, over.
Eagle Ray, Ocean Explorer, go ahead.
Tag deployed, and we will mark location on the GPS.
Copy that, nice work.
The tag is designed to release after 8 hours and send a signal to help the team locate it. Somewhere in the middle of the Atlantic.
It is an intense feeling to spend all this time on something and then watch it just go into the abyss on the back of a whale.
Oh, what's this direction in front of us?
Confirm you have visual on the tag.
Affirmative. We're looking at something orange in the water. It could be the tag.
Roger that.
We are making our way to your location now, over.
I see it.
We have visual on tag.
A little bit more, Aldo. Yeah, there you go. Right there.
You got it?
Yep,
Heavy.
got it.
I'm dying to know, how does the tag look?
The tag does look in good condition, and the camera looks like it's still dry.
Yes. All right, great job, guys.
Should I cut this?
Yes, please. Now it could be some water inside, so we need to be careful. Very slowly, very carefully.
I'm like excited and nervous at the same time, like, did everything work properly? Did the batteries last? Like,
Yes.
got it?
Take it off. It's dry.
Okay, and then there's our SD card. You got it?
I got it. This is it. This is what we've been working all this time for. Let's plug this to the computer and see.
Okay, yeah.
Okay? Anything that comes off this thing is new.
Oh my God!
That's the blowhole, and it's going down because it's getting darker.
As they dive, sperm whales undergo an incredible transformation. The pressure of the water compresses their lungs, and with less volume inside, they become less buoyant, allowing them to dive faster with minimum effort. As she dives faster, the force of the water pushes the camera sideways. At 450 feet, it flips.
It's pointing backwards?
Yeah, it's pointing backwards. We can actually see the flukes beating.
Eric and Rui are the first people ever to see a sperm whale use its body and tail flukes to dive into the deep.
I'm learning a lot about how they actually flex their flukes. It's very slow, it's very calm.
Then, at 900 feet, the whale's behavior changes.
Look, the tail stopped moving.
Yeah, it's called gliding. They use the momentum that they have to glide and keep energy.
I see.
And I've never seen it. So it's just amazing.
Its tail may have stopped moving, but this whale is still diving. With gravity doing the work, it can save energy and preserve precious oxygen.
Listen. It's hunting. This is the hunting sound.
Yeah.
Sperm whales use sound to hunt in the dark. When their sonar clicks hit an object and bounce back, the whale can locate a target over a mile away.
It's getting lighter in the background. You notice that?
Yeah, the water is becoming clear.
No luck this time, so the whale begins its journey back to the surface.
I hear a slightly higher pitched clicking.
It was a coda.
It's communicating with its family, just like Morse code for whales.
Another one. Someone is answering.
Each family unit has a unique coda that can be heard from up to 2 miles away.
Whoa, two!
Another one!
This is how a surfacing whale reconnects with its family.
So you hear the codas, and then the other one comes in.
Yeah. Do we know that they do this?
We know that they talk to each other using codas, but I've never seen them come together.
Oh, I can't believe we got this all.
They are completely interacting. Nothing like that has ever been filmed. It's just amazing.
We are seeing something that has never been seen before. These huge whales go into a part of the world that we know almost nothing about, and we get a first-person view. I'm right next to Rui, and he's spent his entire life trying to understand these animals, and this is something he's never seen before.
Once back at the surface, some sperm whales spend their time socializing. Reestablishing family bonds. Others grab a quick power nap. But their time together is brief. After just 15 minutes, they'll dive again in their never-ending pursuit of prey. Sperm whales eat up to a ton of squid a day. And with nearly 1,000 sperm whales here, that's a lot of squid. So what kind of squid are hiding down there in the depths that could satisfy such voracious appetites? To find out, the team need to get down there themselves. – The mission will be led by Zaleka, the Ocean Explorer's deep sea researcher.
For this mission, I'm partnering with Edie Wooder, one of the world's most experienced deep sea biologists.
You ready to dive?
Yes.
SO Neptune, we are ready to shut hatches.
SO Bridge, you are clear to roll sub out.
Edie's been pushing the envelope in ocean exploration for over 40 years.
That's Neptune in the water. Venting now.
Depth 20 meters, vent secure, descending, over.
Every time we dive into the deep, we are heading into the unknown.
We are explorers, and this is our spaceship.
600 feet down, the team enters the twilight zone. A world dominated by darkness and alien creatures.
Oh, look at that, look at that.
What are you seeing?
It's a glass squid, a rare sighting.
Being transparent, that's a defense mechanism. It's such an amazing adaptation. You see it a lot in the ocean, but you don't see it much on land.
At 1,500 feet, they find even more signs of life.
What is that? What? Look, turn to the right, turn to the right.
It's ink, but it's so much.
Oh my God.
Where's the squid, though?
Oh, squid.
Squid.
A bird squid.
Hello.
Hello.
And this one has attitude.
Oh my gosh, it's went.
Beautiful. Oh, look at this. Going in.
I think he's trying to eat Zaleka.
Yeah. It's good food.
As the sub dives to 2,500 feet, Zaleka spots something extraordinary.
Oh my word. Is that a whiplash squid? Look how exquisite it is.
All squid can change color by expanding or contracting cells in their skin called chromatophores.
Do you think it's signaling to other squid? Yo. Is this an alarm signal? How does one even decode what we're really saying here? I'd like to think I'm a level-headed scientist, but wow. When you come across an encounter like this, it's absolutely stunning. Absolutely stunning. This is why we do it, Edie.
Sperm whales do prey on whiplash squid, but they're so small they'd need to eat thousands every day. At 3,300 feet, they approach the boundary of the midnight zone.
The midnight zone is pitch black, and it's freezing. But as hostile as this place is, this is where the sperm whale finds its food. So it's important that we go take a look down there.
But the sub reaches its maximum dive depth. It can't go any farther.
Control, control. Neptune passing 50 meters, clear to surface.
If they want to search the Midnight Zone for larger sperm whale prey, the team will have to mobilize the ship's ROV, a remotely operated vehicle.
The ROV is capable of going to depths of 20,000 feet. So getting to 5,000 feet where the sperm whales are going should be no problem at all.
Melissa baits the ROV with Deepwater Squid's favorite meal, other squid.
And that is a squid ready to be lifelike in the water column.
Through its tether to the ship, the ROV sends back a live picture.
Exploring the deep, you often see something that you have never seen before, but you hope that you're going to see something no one has seen before.
Lights off.
Oh, incoming, incoming. Here we go. Whoa.
What is that?
Bingo. Kitefin shark.
The squid lure has drawn in more than the team bargained for.
He looks like a good size. These guys can get up to like 30 pounds on average. Sperm whales, yeah, they do eat them, but actually have a preference for squid.
After hours in the deep and just one encounter with the kitefin, the team wonders if the noise from the ROV could be scaring off the squid. Time to try a different approach. Marine biologist Nathan Robinson has the perfect camera rig for this mission.
The Angler is a stealth camera, makes no noise. It's also very light sensitive, so this actually really is perfect for seeing animals in the deep sea. Going down. 8, keep letting it go.
Lowering the angler on a fishing line may look low-tech, but this is our secret weapon. It can dive to 6,500 feet and then just sit there, completely silent and still, so as not to scare away any wildlife.
The Angler is armed with an E-jelly, an LED array that mimics the defense mechanism of the Atolla jellyfish, which lights up when threatened to try and attract an even larger predator in the hope that it will scare off the attacker. After hours in the deep, the rig is ready to be retrieved. Only once back aboard will the team discover if their covert mission has been a success.
Right. You ready to bring it to the lab?
Yeah.
Okay, so now we're going down to the bottom. Oh my God, what a catch.
These flying squid are known sperm whale prey.
We've been seeing a ton of squid conducting these hit-and-run attacks on the bait and the e-jelly. They are large, very nutritious food items for something like a sperm whale.
Hours into the footage, Nathan and Eric spot something even larger, and they gather the rest of the team.
Just watch this.
That is a really big squid.
So this species is the third largest in the oceans.
Dana octopus squid is the common name. It's got light organs on the ends of its arms that are like the size of lemons. Look at them. They're glowing so bright.
Why would you have such bright lights there?
To blind you.
Oh, it's like a deer in the headlights.
Yeah.
So you've got your little critter, your little crustacean that you want to eat. You shine these big kind of lemon-sized lights right at it. It can't see what's coming from what direction, and then bam, you take it down.
Weighing as much as a full-grown gorilla, a sperm whale only needs to hunt 5 of these giants a day.
This is actually the most common species that sperm whales eat in terms of weight.
This is actually
This
staple
is-
food. This is
Exactly.
number one
This
thing in
is
their
what
diet.
they're eating, yeah.
But they've hardly ever been seen.
I'm actually pretty sure this is the first footage we have of Dane octopus squid in the Atlantic.
This is amazing.
Thanks to the Deepwater team, we've seen squid down there large enough to feed this huge population of sperm whales. But what's fueling this rich ecosystem? It's all down to the tiniest organisms in the ocean. When deep ocean currents hit the island's underwater slopes, nutrient-rich water is forced up toward the surface. These nutrients feed microorganisms that form the base of the food web. And the more there are, the more life this ecosystem can support. To find out just how rich these waters are, Edie and Zoleka once again take a dive into the deep. The density of this microscopic life is difficult to judge in these dark waters. But Edie has a magic trick to reveal it.
$600
Oh, I hope this works.
Okay, you ready? 3, 2, 1, lights coming on.
Nothing. Let's drop down.
Control Neptune, we are descending.
Okay, let's try it again.
Okay, 3, 2, 1, lights coming on.
It worked! Wow.
bioluminescence in action. It's like I'm wrapped in a blanket of stars. This is the base of the food chain. The fish eat the plankton, and the squid eat the fish, and then the sperm whales are feeding on the squid. This is where it all begins. Smallest to the biggest.
That's fantastic.
Edie's witnessed this bioluminescent phenomenon her entire career, but has never had the technology to share it with the world. Until now.
Well, thanks, Edie. We got it.
It's like having seen UFOs, and now suddenly there's evidence. Okay, can we do that again?
Absolutely.
Without this abundance of tiny life, the squid and the sperm whales couldn't survive here.
It's very, very humbling to think that no matter how tiny you are, you can do gigantic things.
Control, Neptune's ascending, over.
Clear the surface, clear the surface. Welcome back, Neptune. Blow your tanks.
Did you enjoy that dive?
Oh, are you kidding? That was actually on my bucket list. You know, as I get older, every expedition I go on, I figure this might be the last. And if this is the last, it's the best. It's just been absolutely amazing.
In their time here in the Azores, the team has captured the first ever images of a sperm whale diving into these deep waters.
This is the culmination of a huge amount of effort and many sleepless nights. But at the end of the day, we got those few minutes of incredibly priceless footage that made the whole thing worth it. It was awesome.
They've added to the image catalog of the squid that feed the sperm whales.
Thanks to the Ocean Explorer, we've been able to dive deep into the world of sperm whales here and discovered this interaction between them and massive squid that's never really been observed here before, which is pretty mind-blowing.
And they've documented the normally invisible riches that fuel this entire ecosystem.
It's fabulous.
I am one of the few people to witness a bioluminescence light show, and I'm so excited to share this with the world. That is mind-blowing.
We've still got so much to learn about these whales, but seeing them live in harmony, they could definitely teach us a thing or two.
No!
From the largest to the tiniest creatures. The team has made significant discoveries here in the Azores.
Nothing like that has ever been filmed.
A rich hotspot for life in the Atlantic and a blueprint for healthy oceans everywhere.